Hey, Jamie.
Hi, Derek.
Afternoon.
Oh, there's Samantha. Awesome. And good afternoon to our viewing audience. Thank you, Bob, for that heads up that we are live. Glad you could all join us. What do you say, Sam? Should we go ahead and put the welcome slide up?
Sounds good.
That way everybody knows they're in the right place. There comes Danielle. So welcome, everybody. We are just getting started with the Oregon Department of Fish and Wildlife Beaver Management Work Group on this lovely Wednesday, October 13th. Please note that this meeting is a little longer than previous meetings. We're scheduled to go from 2 to 5. Sam and I were just talking about, we'll probably take a little break after our two speakers before we go to a large group discussion, because 3 hours is a long time to sit in one spot. So we'll probably take a 10-minute break about right after our two speakers. Oh, here comes Shannon. And for those of you in the audience who maybe this is new to you, I'm Jamie Damon with Kearns and West, and I facilitate these meetings. And there we go. Okay, Zoom meeting tips, same as always. We ask that you keep yourself on mute when you're not speaking, and use your video as much as possible. We understand if you need to eat a sandwich or step away, no worries. But we'd like, if we can have video on as much as possible, it helps our viewing audience as well as helps all of us feel like we kind of are actually in a real meeting together, so that's a nice thing. You see Sam's number there if you have any technical difficulties. Phone number is 360-536-3660. Let's go to the next slide. This is just a screenshot of what it looks like for our meeting participants. You have the ability to mute and unmute yourself, turn on and off your video. I believe everybody has named themselves, so that's great because then everyone can see who you are. When it's time to speak, if you have something to say, use the raise hand function. I'll do my best to put you in the queue. And note that the last meeting, we had a little issue with the chat. We had kind of a lot of things happening in the chat. And a couple folks pointed out that it's like, hey, our viewing audience can't see what's happening in the chat. And even though the chat becomes a part of our meeting record, we would ask everybody to really refrain from using the chat. And unless there's some issue that you want to alert Sam and I to, or just try not to have a sidebar conversation, or let's try not to use the chat as much as possible today. We're going to keep it open. I'm not going to turn it off. I'm not going to be, that heavy-handed. But let's just try to be verbal as much as possible. So let's go ahead and go to the next one. So our meeting today, like I said, we're going until 5, so it's a little bit longer meeting. And we polled the group in advance, and I think pretty much everybody can stay. I understand if anybody needs to leave early. Actually, let me just see a show of hands. Is there anybody that needs to leave before 5? I'm not seeing anybody. All right, thank you for that. Nice to know that we have a critical mass all the way through to the end. So we have 2 guest speakers with us today. Our guest speakers were identified by a subgroup of the subgroup. We have a big list of researchers that all of you have contributed to, that ODFW has contributed to. And as we took a step back and thought about, what information would be most helpful for the group at this.
Jamie, has it frozen up for everyone else? Okay.
Yes.
All right. Yeah,
Yeah.
Jamie, I think we lost you there. So I'll just go ahead and continue the overview of the agenda. So as Jamie was mentioning, we've pulled together these two guest speakers, and the first one will be Jimmy Taylor, kind of giving an overview of Beaver Biology 101. So this is going to be really foundational pieces relating to beavers, the animals. What are they doing? Where are they living? What are their behaviors like, and just grounding us in that foundational knowledge. And then we'll hear from Michael Pollock, who is a researcher with the National Marine Fisheries Services, and he will share with us a Beaver Ecology 101 presentation covering a lot of his modeling work, and also providing that foundational piece in the beaver habitat and kind of what beavers need in terms of their habitat, how they modify habitat, and where where they move throughout the landscape, covering those dispersal questions as well. And then we'll take a quick break, as we talked about, after those two presentations, and then move into a group discussion and involving our guest speakers and being able to ask them any questions about those foundational pieces of beaver biology and ecology. And then we'll move into our next steps, upcoming meeting topics, and summary. Sound okay? And so anything else to add to this agenda before we move into the meeting guidelines? I see a thumbs up here. All right. So our meeting guidelines, we should be all very familiar with these. Just they're here again as a reminder to fully participate in the work group meetings. Alternates are in listen only mode. We ask that you come prepared for the meetings. Of course, you're already here, so hopefully you have done your preparation in advance. We ask that you participate in an open and mutually respectful way, that you honor the balance of speaking times, serve as a liaison to your larger community, act in good faith, and as much as possible, leave baggage at the door. All right, Jamie.
And I'm back. See,
And
Wayne,
back.
you're not the only one, Wayne, with technical difficulties.
Happens to all of us.
Happens to all of us every once in a while. All right, what slide are we on? Sam, thanks for stepping in.
So just moving into this little overview here.
Okay, so we thought it would be good just to take a couple of minutes to remind everybody about the mission and the scope of authority. These are pulled straight from the charter, so there's no surprises here. And it's just good to remind ourselves of what it is that we're trying to do. So again, the mission is the work group is developing recommendations to ODFW Commission to consider regarding ODFW policies, practices, and programs related to beaver management on federally managed public lands. And the scope of authority is the work group will assess current and historical approaches by ODFW for beaver management on federally managed public land within the agency's scope of authority. The work group may include consideration of other local, state, and federal agencies, as well as NGO programs and policies and current and relevant best available science as they relate to greater coordination, communication, and potential partnerships as they develop recommendations for the commission. So just a little reminder about the mission and the scope, and for those in our viewing audience, if you haven't seen this before, this is what the work group is all about. The other reason why I put this slide up is because this represents a level of agreement that the group has reached around the mission and scope. We had a lot of conversation about this. The next slide also represents a level of agreement, which is our shared value statement. As you recall, the first few meetings, we spent a fair amount of time trying to convince each other about the value of beaver, and we ultimately all decided that yes, we do value beaver and beaver's role. on the landscape. And so let's, we don't need to fight about that anymore. And so this is the value statement that the group has adopted. So let's go ahead and go to the next slide. So this is where, we introduced this at the last 2 meetings. So the subgroup thought it would be helpful to narrow down on kind of this key question, that if we value beaver modified landscapes, beaver modified floodplain landscapes, and we're focused on federal land, and we specifically are interested in the dam building activity that beavers can do. If the beaver floodplain landscapes on federally managed lands are not as prevalent as they could be, why? What's going on there? And so, there's 2 parts to that. One is the limiting factors and what do we know and don't know about habitat biology and management. And then there were some limiting factors that the group identified, including population dynamics. If you recall at the last meeting, folks were wondering, it's like, hey, where is harvest? It's part of population dynamics, as well as prevalence on the landscape, disease, predation. It includes suitable habitat, legacy habitat, dams. What are we seeing in terms of historic, current, or trends? Resources around staffing and funding for agencies, for management, and the social science component. And then on the management options, we've been talking some, and we heard from Derek and Shannon. I don't know if we heard from Kevin at the last meeting, but and Tom about, kind of what are the range of management options that ODFW has at their disposal to address limiting factors. And these are some of the things that we've heard from them. So these are the things that we're trying to unpack and understand. The next couple of presentations that we've got are really focused around habitat and biology and management. And we've heard some presentations about pieces of these already. But our hope is that after this meeting today and the meeting at the end of October, that we will have a good amount of information that we can start to put on the table, some ideas that could form the basis of recommendations. And we'll work together with all of you. If you feel like there are other foundational information pieces that we should be putting together, connecting with presenters around, or other scientists you want to hear from on specific topics, we can work to make that happen. So, and this is my last slide, and and I put this out here because these are all my words on this slide, and I, as well as many people around this table, have worked on a lot of issues that have a complex technical component. And we can get wrapped around the axle of of sort of what science do we trust, what science is the prevailing science. That's why I called this my science, your science, our science. And the subgroup talked a little bit about this as well. And as you're listening to the presenters today, there's a couple of considerations. We've talked a lot about, does the information meet one or more basic, I'm calling it basic scientific tenets? Peer reviewed, is it cited, is it broadly supported, has it been validated? It may be, multiple of these, it may be one of these, but just, that's a good filter to keep in mind, as we're trying to pull science forward. Is the information applicable to address our issues? Is it similar landscape, scale? Are there similar issues addressed? And then where are the gaps? I mean, what more information is needed? Where might there be the potential for additional research opportunities, or to apply some things that we're hearing, to our conditions here, or the issues that we're trying to address? So just some considerations, as we're listening to the speakers today, and at the end of the month, and as you're all, many of you have identified papers that you wanted to bring forward, and we've distributed those, we've heard some pushback from people about, it's like, hey, why is that sent out? And how about, why not this? And so send us things. We're happy to send it out for the full group, and you can all make your own opinion about, what information you want to pull from. I thought it would just be helpful to have some, just a reminder about, science in many ways, is a conversation. It is all about discovery, and we're doing our best to bring forward information that will be helpful. So I think those were all the grounding slides that I wanted to share. So if we're ready to hear from our presenters, so we've got the two presenters, the way we've talked, when we talked to Jimmy and Michael, so Jimmy's going first, and we've got they both have about a 15-minute or so, 20-minute information to share out. They said it's fine to interrupt them with questions, as they're going along, that feels a little bit more conversational. And then we also have a good half hour plus, or half hour or so with each of them, to dive in deeper and have a conversation. And then we'll take a break. And then we'll come back and we'll have a full group discussion about, either other information that we need, trying to connect the dots around maybe floating management ideas, wherever you want to go with them. And we've got them for the whole meeting. So, but they both said they're happy to be interrupted. I'll manage that. If it looks like, it's too many interruptions and they can't get to their information, we'll just manage that time. All right, are we ready to go? Okay, Jimmy Taylor, you are on. Introduce
Okay, let's
yourself
see if
and let's go.
okay, there might be a slight lag in this. Okay,
There it
can you
is.
see that?
Yeah, we could see it in presentation mode. That's perfect.
Okay, great, excellent. Well, thanks for the opportunity and the invitation to speak. It seems pretty easy to just talk about basic beaver ecology for me. I've been working in beaver wetlands for over 20 years, but really I found it more challenging as I started putting this together because I know a lot of this stuff is just going to be, common knowledge to you, but I really wanted to start out and throughout this short presentation, kind of stick to things that we know or we think we know, and maybe address some things that we don't know so much about, and really tie that to the published literature, mainly the peer-reviewed literature, but also I might interject some information from case studies or other things like that. But I'd like to just start out by just acknowledging these references here. Most of these are book chapters or books themselves that have pretty deep reviews of beaver. And I'm not going to stay on this slide, but I just wanted you all to know that a lot of what I'm going to talk about comes from these sources. And if anyone's interested in getting these full citations or reprints even, you can let me know after the presentation. I'd be glad to send those to you, or anything else that I mentioned during the presentation for that matter. But just to start out again, just with some basic information, this is the distribution map or the range of North American beaver in North America as we know it. There's some different maps that may shade in a little bit more of the Southwest or a little bit more into the Panhandle of Florida, or maybe draw back from the Arctic region more. But this is the general distribution as we know it now. Really quickly, I want to shift to something that I would submit to you we really don't know, and that is we don't really know what the historic population size was. We don't really know what the current population size is, and that's okay. I think it's okay to acknowledge, areas where we need more information or we wish we had more information. We can't really go back in a time capsule and do a survey for beaver. But the one common citation that I see is from Seaton's book in 1928, where he references 60 to 400 million beaver in North America. And that's based on just a few estimates approximating the number of beaver per square mile in a few places in North America, none of which, by the way, are in the Western United States. But I actually went to the archives at the OSU library and pulled up this book and photocopied the entire chapter. And I was really hoping to see how he came up with these numbers. And it's really just kind of a back of the envelope. This is how many beaver we estimated in the Adirondacks. This is how many beaver we estimated at this particular park. There's this much water in North America, and here's the numbers. And he did go on to say that he felt like the 60 million was a more comfortable estimate. Yet, we really don't know, and that's okay. We really also don't know what the current population size is, and that's okay too. In Nyman et al.'s publication in 1998, or 1988, they referenced 6 to 12 million beaver in North America. But there's no equation there. There's no discussion of how they came up with that number or if they cited it from someone else. I was not able to find that. Yet that's commonly cited. I've even used it before as a general reference. But again, we really don't know. And I've also seen a reference to 1 million beaver in Oregon from Guthrie and Settle, 1988. And that's actually two faculty members at OSU that wrote this in a Fisheries and Wildlife, just a bulletin article. Again, it's okay that we don't know, but again, there's no math there. There's no estimate of where they got that information. It's really difficult to estimate the number of beaver in a state or across North America throughout the range. And it's mainly because of their secretive nature. And this is not uncommon for wildlife. It's one of the hardest things that we try to do as wildlife biologists is estimate population size. There are ways that we can try to get these numbers with some measure of confidence, but there's no common way to do it. It's pretty easy to say, oh, there's a beaver, but they're nocturnal species, and doing night surveys trying to identify beaver by sight is pretty difficult. So that's not a really good index. We can see dams, and we know that beaver build dams, but there's no direct relationship between the number of dams built and number of beaver associated with that. Not all beaver build dams. Some build a lot of dams. Some dams are ephemeral. So, even if that were an index, you'd have to be counting at the right time. There'd have to be some really good equation that associated with some number in the number of dams you see. Very similar for lodges. Lodges are easy to spot and easy to identify as, there's beaver there, but not all beaver live in lodges. Some live in bank dens, and those are extremely hard to find, especially if you don't know what you're looking for, or if you're looking in the wrong places. So again, we don't really know how many are out there, but we want to know more about that. And there's ways, again, that we can get to estimates. It's just not a universal technique that we can apply to any location. Enough said about that. I think we may come back to that later. If there's questions about that, I'd be happy to try to entertain them. But just to start out with some more things that we do know, beaver are rodents. They're members of the order Rodentia, and they are of the species Castor canadensis. There's only one other species from the genus Castor, and that's Castor fiber, the European beaver. And you can track back their lineage to when they separated, millions of years ago. But they are similar in appearance, but they are genetically separate. They do not interbreed. Okay, we refer to them as semi-aquatic animals. That means they can move on water or land. On land, they're very clumsy. In the water, they're very fast and agile. And it's the aquatic environment that they spend the most time in. Some spend almost exclusively their lives in the aquatic habitat when they have access to forage and don't have to leave the water to forage. When they have to get on land, they're slower, they're more susceptible to depredation and so forth. And their bodies are adapted to the aquatic life more so than the terrestrial life. They can hold their breath underwater for 15 minutes, for example, and they have special lenses that cover their nasal cavity and their eyes that protect them underwater. And they've got several other adaptations that are really cool. They're a long-lived species compared to other rodents, for example. In a study that I conducted in 7 eastern states, we looked at the cementum annuli and teeth from dead beaver and found that they ranged in age from 1 to 20 years old. And there were females in those populations that were still breeding at 18 years of age. So that's very different than a lot of rodents, say house mice or nori rats or other rodent species. They are a social animal. They live in family units that we refer to as colonies. Colony really has a different connotation with other wildlife, but that's what's been used for beaver for a long time, and it kind of sticks. So that's what we refer to those family units as. When we look at their reproduction and development, you may have learned that beaver are monogamous species, and they are mostly monogamous. They're what we refer to as socially monogamous. So that family unit, the male and female that bond and maintain that colony or family unit, they are socially monogamous, but males will also leave that territory, especially when territories are close together, and they are sexually promiscuous with females in the adjacent colonies. And that's something that it's not really new to the literature, but relatively new to a lot of things that we know about beaver. And that was shown through some genetic analyses. The litter size of beaver is generally 2 to 4 young. The average is 6 in some locations, but the range is anywhere from 1 to 9 in the literature. So that's a pretty big range. But again, generally, the litter size is 2 per year. And a colony, well, I'll get to colony in a minute. But also, before I move on, I want to just mention that they do have a very extended breeding season. And this can be different based on the location or the geography of the beaver. It's different between northern states and southern states, mainly because of the climate. But the conception period is generally from November to March, with a parturition period anywhere from February to November. So that's quite a long time throughout the year that individuals can breed. So moving on to behavior, I kind of mentioned earlier that beaver are territorial. The male, who's the head of the colony or the family unit, defends a territory. In a linear environment, in a stream or a river, that's going to be dictated by that section or that reach of stream. In a more open area like a pond or a lake, it may just be a curvilinear piece along the stream, or along the bank that he defends. But that male will mark territory with castor mounds. He'll put his scent out to let individuals know that that's his territory, that's where his colony lives, and he will defend it. And males will attack other males and females that come into their territory. Many times when we live capture beaver, we'll find that they have, bites on them, especially on the tails, and there'll be big pieces of tails missing where they fight with one another. So they are aggressive. They're also referred to as choosy generalists. So a generalist species, has got a broad niche. And when, with respect to the foraging niche of beaver, that's really where the choosy part comes in. There's a lot of published literature that you might see, especially from many years ago, that suggests that beaver prefer aspen, and the best habitat is where there's aspen, or beaver prefer willow. Certainly, they will fell aspen trees and willow trees, and they'll forage on many of those. Whether they're really preferred or not is kind of subjective, but they do have a broad foraging niche. And there are many different tree species that they are known to forage on. They also have been shown to be able to manipulate some trees that have, say, for example, a high monoterpene content. So the tannins or the terpenes in a tree might be something that is not attractive to them, but they will soak those in an area that leaches out those tannins or those secondary metabolites so that they're more palatable. So they're very ingenious in many cases, and that helps them have a wider variety of forage. For periods of the year, especially in the summer, they will forage a lot on aquatic vegetation. So less of the vascular tissue on hardwood stems and more of sedges and tubers and things like that. I have a paper that's in review now where we looked at stable isotopes of the different, of hair in beaver. And we actually showed from our stable isotope analysis that not only are beaver generalists or choosy generalists at the population level or the species level, but they choose different things between colonies, and even individuals within colonies will have varied diets. So they're making choices based on where they are, whether it's referred to as preference or not. I try to avoid the term preference as much as I can, but they are choosing different food types, even at the individual level. They're also what are referred to as central place foragers. So the lodge or den that the family unit lives in is that central piece. And they move away from that in a circular pattern, but in direct paths. They're, in a study that we did, this McClintock et al. Paper, I was a co-author on that. Lance McClintock was one of my grad students. And we used what we called the deliberate movement hypotheses. It was just something that we coined, but we hypothesized that the further away beaver moved from their lodge, the faster they would move with smaller turning angles as they got further away from their lodge or their den. And that's what we were able to show with radiotelemetry is in water, yes, the further they got away from that central point, the faster they moved and a more direct path that they took. And that makes sense because it follows optimal foraging theory, but it's also, it helps them be safer from getting depredated. When they moved on land, we didn't see that effect. They actually moved slow when they got on land, and they're more susceptible to depredation when they're on land, so that's not a good thing for them. But they did, on land, they didn't tend to move as fast as they moved further away or in as direct path. And there's other studies that have addressed central place foraging with beaver as well. It's not something we came up with, just something that we tested with radiotelemetry. Beaver, as I mentioned earlier, do have a social organization. This is where I almost jumped the gun talking about colony size. But the classic beaver colony is 2 adults, 2 subadults, and 2 young of the year. Now, this is not always the case. It's just the rule of thumb, and many times that's what we'll see. But in a study that we did, we found that the range of individuals in a colony was anywhere from a single individual, usually a male that's just wandering around looking for a female in a territory to establish, to as many as 18 individual beaver in a colony. And these are sometimes commonly referred to as super colonies. When you see a colony that large, there's most likely some density dependent factors going on. For example, there's not occupied space for the subadults to disperse into, or they're constrained from moving or dispersing for some reason. It's not really a healthy situation for beaver to have that many individuals in a colony, and it usually means that there are multiple lactating females in a colony, which does not follow their social organization. And it could mean that less young are being reproduced, again, because of density-dependent factors. Yet we do see those sometimes. Beaver home ranges vary widely. They're affected by many, many factors. And again, one of the things that affects their range could be is the system that they live in. So beaver that occupy streams and rivers are going to have more of a linear home range, whereas individuals that are in lakes and ponds or in a series of connected wetlands are going to have more of a typical aerial extent home range. excuse me. In a study that Dr. Mark Boyce did back in 1981 in Alaska, he suggested the minimum intercolony distance for beaver in a linear system, many of which we see in Oregon. The minimum intercolony distance based on territoriality was 1 kilometer. And that's really interesting to me because it's very consistent with a lot of the research that we've done that shows that the average home range for beaver in linear systems is about 1.5 kilometers. Next, I want to talk quickly about dispersal and also other movements. And I'd just like to point out that Bergerud and Miller did classify 4 major movement types of beaver. I'm really going to consolidate that down to 2 because I found that some of his really were similar. But just to point out that there is a difference between dispersal and movement. And when I refer to dispersal in this context, I'm primarily talking about natal dispersal. And that's when those subadults leave their parents, they leave that colony to go set up territories and find mates of their own. And that's the traditional path that beaver social organization follows is, for example, if you have the 2-2-2 colony, around the time the young of the year are born, coincides with usually increased water in an area, runoff, if you will. And so individuals that are those 2-year-olds are going to leave that colony generally around the time that the young are born that year, which again can coincide with changes in water, which make it easier for them to leave and find places of their own. I want to differentiate natal dispersal from movement, and movement can occur for a lot of reasons. It can occur because there's changes in the habitat conditions, mainly water for individuals. There are cases of where beaver have reduced the forage base so much that they have to leave the area. There's a lot of reasons that they could move, but again, that differs from natal dispersal. Sometimes if an individual loses its mate, it may give up that colony area and go search for another mate and establish a new territory. It may eventually come back to that territory with its mate and start over again. But that's movement, not dispersal. We know from some translocation of beaver, some really good numbers on movement. In a study in Eastern Oregon back in the 40s, and this is during the period where there were beaver being moved around to reestablish local populations, about 78% of those beaver disappeared or moved away from the study site. Many years later, McKinstry and Anderson did a study using radio telemetry in Wyoming, and they found that 51% of the beaver that they had marked with VHF transmitters moved greater than 10 kilometers from the study site. We know from other translocation studies that the range of the mean distance moved from the release site varies anywhere from 3.2 kilometers to 18 kilometers. And this is across many states and also in Canada. The maximum distance moved when beaver are translocated into a new area ranged from 29 kilometers to 238 kilometers. So just as a quick reference, that's like swimming from Portland to south of Eugene, like it's around Cottage Grove. So that's a long way for beaver to move, but they do that. And we still, even as much research as we've done with beaver, we don't really understand what those proximate and ultimate cues are that cause them to settle in a spot and establish a territory. So many cases, even in the modeling exercises that we've done here in Western Oregon to pick the best of the best locations to release beaver and where those beaver would have the most impact for increasing intrinsic potential of coho, we still weren't perfect with our assessments. We still had beaver that moved up to 29 kilometers away from where we released them. There have been two published studies so far that look at survival and movement of beaver that have been translocated using radio telemetry. I mentioned the McKinstry and Anderson study earlier. That's one of them. That was the first documented case. And then our work in Western Oregon with Vanessa Petro's thesis work and the work she's done from that was the second. And we found very similar survival rates immediately after releasing beaver. And most of the mortality occurred very quickly, and it was most associated, in our study at least, with depredation by cougars. Dwayne Jackson with ODFW did another study in southwestern Oregon, and his results were very similar to ours. And that study was not published, but very interestingly, we found a lot of the same cause-specific mortality and survival. And there is another study that was recently conducted in Utah by a graduate student at Utah State University that will hopefully be published soon. And her survival rates were pretty similar to ours, I think around 50%. So when we talk about population density, again, this is, there's a lot of variation in this. Some of the published literature and reviews by Hill and Novak suggest that the number of colonies per square kilometer ranges from just above 0 to 4.6. There's been other studies that have looked at the maximum population density, or what's referred to as a saturation rate. And those have been reported to vary from 0.4 colonies per kilometer of a linear system or a stream to 1.2 colonies per kilometer in New York and Utah, again in reviews by Hill and Novak. In a study that Hill conducted in 1976, he found the saturation rate in 4 headwater streams in Alabama approached almost 2 colonies per kilometer of stream. If you remember, I said earlier, we found that in areas that we consider at carrying capacity, we have beaver that occupy territories of about 1.5 kilometers along a stream. So if there's 1.9 colonies per linear stream, there's probably a lot of fighting going on in these areas, and that's pretty atypical of density. So that area, I would suggest, is probably at or above its carrying capacity as well. So these are very atypical numbers. Population density can be affected by a lot of things, including trapping, water quality, habitat suitability. I won't read all of those to you, but each of those can and does affect population density. And many times they can operate together to affect population density. It's usually not just one or the other. Population density also may vary as a function of the length of time that sites have been occupied. And what I mean by that is there are examples in the literature of where when areas are reoccupied by beaver, there's an initial slow growth for a number of years. And then there's a rapid growth for a number of years. And then there's a rapid decline for several years. And the population tends to stabilize at some point, which is always less than its peak that it reached at the rapid growth rate. And so there's examples of this in both Massachusetts and California. We should also consider when we're evaluating changes in beaver populations that there are both intrinsic and extrinsic factors. And that fluctuation that I just mentioned, those examples from Massachusetts, are likely related to intrinsic factors that are not just associated with things like trapping. And so, again, we need to consider all of these things when we're talking about changes in population. Moving along quickly, I'm not going to go into these different models. I just wanted to mention that there are a lot of beaver models out there that have been developed to look at the habitat suitability indices for beaver, to estimate where beaver dams are located or the intrinsic potential for beaver and so forth. Many of these models, most of actually, are built on presence absence or presence pseudo absence data. So we see beaver in these areas, or we see dams in these areas, and we capture all these data and we try to project from that areas where we think other beaver should be or other dams should be. So there's a lot of them out there. Some work with some level of accuracy in the general area that they were created, but there's really no model that works well everywhere. And some really don't work that well anywhere. You know, the Allen et al. Model was the habitat suitability model that the U.S. Fish and Wildlife Service built back in the late 70s, early 80s. And that's the first one that I mentioned here. It's a very general model, and others that have tested it in other areas found that it wasn't really applicable, although it may have some application in some places. In some of the more recent models, we use things like machine learning to develop species distribution models and predictive surfaces and things like that. The Berea et al. Paper I was part of, this was a graduate student that I had recently. And this was a really interesting study, a really interesting data set, because we did tie survival into habitat suitability. And that's kind of where we want to go with future studies, at least from my perspective, is not only looking at areas that are suitable for beaver, but how is that related to their survival and their vital rates. And we predicted that as habitat suitability increased in this particular area, that survival rates of beaver would increase. But we actually found an inverse relationship, which may suggest that the population that we were studying had actually reached or exceeded carrying capacity as well. So just, quickly again, the more suitable the habitat appeared to be, that had a negative effect on their survival rate, which was contradictory to our predictions following niche theory and ideal free distribution. But I'm interested in doing more studies like this. To me, that's just, it was amazing, it's informative, and I think that we really need to include things like looking at survival as we move further. I haven't been keeping track of time, but Jamie, if I'm starting to go over something, just cut me off.
Yeah,
But,
you are. You're starting to go over. We
okay,
want to make
I'm
some
sorry.
time for a conversation. It's okay. It's
Yeah.
good information. I think you're probably wrapping up.
Yeah, I am wrapping up, and I'll try to do that really quickly. I'd like to wrap up by just mentioning some ways to look forward from my lenses anyway. This paper was written by Dr. Ellen Wall, who's a fluvial geomorphologist at Colorado State University. It just came out this year. The title, Legacy Effects of Loss of Beavers in the Continental United States. And I'm just going to hit really quick some points that she made near the conclusion. And it kind of has to do with how we move forward in looking at case studies and applying those to using beaver naturally in the landscape, or using beaver-related restoration to try to mimic the effects of beavers and beaver dams. So she just points out three things that I'll hit really quick. Three preliminary inferences or things to focus on. One is that local site-specific details can strongly influence the effects of beaver activities or beaver dam analog installation. And some examples that she gives are that beaver dam analogs can raise floodplain water tables, but they may have no effect on the water table in losing reaches, or where local conditions limit infiltration from the channel. Also, beaver-created inundation can significantly increase methyl mercury concentrations in areas that were not previously inundated. And this is shown through some work that she and others have done, which would have a different effect in an area that had previously been inundated. The second thing that she mentions is we need more comprehensive quantification of the effects of beaver modifications on river corridor budgets for materials such as water and carbon. I won't read these to you. I'm happy to provide them later, but I do need to wrap up. But the gist of this to me is that we can go into planning expecting one thing, but we may find other things, such as, we may feel like, increasing water storage is going to happen, but that could have a deleterious effect in other areas. Lastly, she warns that we cannot yet infer scaling effects. So some questions that she poses here are, one beaver dam or one dam pond pair cannot effectively attenuate a large peak flow, but can a beaver meadow complex with multiple dams and this anastomosing channel planiform, which is these connecting streams weave together and dense riparian vegetation effectively attenuate a peak flow. Can one beaver meadow or several beaver meadows significantly increase watershed scale denitrification? And he submits that these are the kind of questions that we should be asking, and I concur with that. I think that's really forward thinking. Lastly, I'd just like to mention another cautionary example. Currently doing some work with my graduate student, John Stevenson, in the Umpqua. He's finding water temperatures that are below beaver dams in the Umpqua River Basin are warmer below the dams. And that's in line with some other studies that are published that show warming effects below dams. But there's also other studies that show mixed effects, cooling below some dams, warming below other dams, and that may be related to the head height of the dam. And then there's other papers such as Weber et al. That suggest that downstream warming is cooler. So again, my cautionary example here is just so that we think about all studies when we're planning and making decisions, and not just, I don't want to say cherry picking, but, we need to consider all alternatives, all possibilities. So sorry for going over with that. I'm here for questions for as much time as we have before Michael talks.
Thank you, Jimmy. Are these dam instructions provided by IKEA?
Can't remember where we got that.
Hi, Jill. I see your hand up. Go ahead.
Yeah, I just had a quick question about when you talked about affected by density dependent factors, and was that just referring to one beaver colony, or would that be, say, if there were multiple dens and multiple lodges?
I think it could be either. Some examples of density dependent factors may be the availability or accessibility of food to individuals in a colony. So if those resources are depleted, that's not good for their survival. It may cause them to have to leave that area. It may cause them, if they can't leave that area, that they're absorbing fetuses and not having young, or it may cause increased mortality in young beaver. It may cause them to have to walk on land to forage, which makes them more susceptible to depredation. So that could be happening just at a localized level with a colony, or it could be happening over a larger area with multiple colonies.
Okay, thank you.
Mm-hmm.
Jefferson.
Hi, Jimmy.
And then Bob. I see, Bob, your finger's up, so I wanted to acknowledge you.
Thanks for the presentation. And I just closed it by mistake. I appreciate you differentiating between movement and dispersal, because I think in a lot of discussions we have, those two get conflated, and that information around a translocated animal in regards to its movement, or more importantly, its mortality, is associated that's the mortality of beavers writ large, rather than that represents mortality just of translocated animals, which are kind of in a different situation. Is that a correct summarization?
I think so, Jefferson. Yeah. There could be a lot of stress involved in getting, plucked out of where you lived, anesthetized, driven several miles, and dumped out into a new place where, you have to try to keep your colony together. You've got to survive yourself. You've got to find food. You've got to find escape from predators and all that. So, yeah, the movement that we see is likely associated with all of the stress involved in, trying to stay alive and keep things together.
And so, but that's mostly where we get our mortality stuff. We don't have a whole lot of questions from or data from non-translocated animals in terms of mortality.
There's not that much out there. I didn't dig into that for this presentation. With more time, I should have and would have. But those are areas where we'd like more information. And the graduate student that I mentioned earlier, who just finished up at Utah State University, she had radio tags on both beaver that were already in the system and beaver that she translocated. So when her results are published, there'll be some new information there that will be informative.
Okay, Bob, you're up.
Jimmy, thanks much for summarizing what you did summarize. I had a question though. You gave some colony densities. Do you have any guesstimate as to, or is there any literature that talks about the average number of dams, if I can put it that way, per colony? Is there anything out there that you're familiar with or aware of?
Yeah, that's a good question, Bob. In terms of like a predictive model, I'm not aware of any that are out there. There may be. Nothing comes to the top of my mind, but I'm currently working on a book chapter with Steve Wendell's, which is going to replace one of those references that I led off with. And we still got some more work to do. And if I find anything related to that, I'll let you know.
Okay, and one other thing, you started with a historical discussion and some historical estimates and indicating that who knows how accurate they are and all that, but the one you had from Dan Guthrie and Jim Siddell was actually in the current population estimate category, and that the number there is actually a historical estimate prior to trapping. So the 1 million that you show in current estimate is really their estimate of what was present prior to significant trapping. Their current estimate in 1988 was a lot lower, like 70,000, so 7% of historical. So, and I've been trying to dig up numbers, estimates and stuff like that. And the 7% less than historical is pretty, I won't say consistent, but certainly the numbers I've seen are all well less than 10% of what was here historically. So the 1 million that you have on the front slide is really a historical estimate. The contemporary estimate for them by Dan Guthrie and Jim Siddell was really 70,000.
Okay. Yeah, thanks for pointing that out. I appreciate the correction. I think my point was more that, in digging around in some of this, I was hoping to find out how they calculated it.
Yeah, I was too, and you can't find out.
Yeah.
I don't know how they do it, but anyways, you're right.
Brian?
Yeah, hi, everybody. Thanks for the presentation. Sorry if this is too direct a question for everybody, but what is human-caused mortality a limiting factor for beavers on federally managed public lands? And what's your opinion in that regard based on? And if it's you don't know, that's totally fine.
Brian, was that question for me or just the general?
For you. Sorry if I didn't make that clear.
Okay. So I'm not aware of any information that suggests that trapping, whether recreational or for damage management or a combination of, is limiting beaver on federal lands. I'm not privy to any of those data. I don't know that they exist. I think it would be great to find those if such data do exist for these discussions, but I'm not aware of any. There have been, this is, it's not a direct answer to your question. That is my answer to it, but it did bring up one other thing that I didn't mention in the presentation. There have been studies that have looked at what happens when areas are lethally trapped. at different levels, including trying to locally eliminate beaver colonies over large areas. There's a study on the Ames plantation at Tennessee that covered several hundred square miles, where they removed a large number of beaver, and then immediately beaver dispersed from other colonies and quickly filled those areas. And that's consistent with a lot of other information in the literature where trapping has occurred. And heavy trapping over long periods of time will tend to take a lot of the adult beaver from the population, and but it does not decimate the population. It may cause things like younger females to have young, and beaver can have young, as young as 1 year of age, where if there's pressure to do that because of the population structure, then they can, and that helps repopulate the local population.
All right, thank you for that. We've got Amy and Samantha, and then we probably should think about switching over to hear from Michael. Amy?
Great, thanks, Jimmy. I took a ton of notes from your presentation, and I know more than I ever think I wanted to know about beavers. But one thing I wanted to ask about, if you'll spend a minute talking about, is when do beavers build dams? Like we talk a lot in this work group about the ecological benefits of the dam building and what that can do. So you mentioned, some of them build lodges, some of them are bank denning, and sometimes they're not always building dams. So can you explain a little bit more about when and why that might happen, of what we know there?
Sure, Amy. Yeah, I'll try to do that. So as I alluded to earlier, beaver live in a variety of different wetland habitat types, from small streams to large streams to rivers to lakes and ponds and sloughs and swamps. They can live in a variety of places and do well. I think, in my opinion, the best habitat for beaver are in areas where they do not have to build dams, where they've got escape from predators in deep water pools or wide streams, and they've got easy access to food, and they can live in bank dens that they create. So those type of beaver traditionally don't spend a lot of time out on the ground, and they don't have to build dams. They can be lazy beavers. They can still contribute to ecosystem services, but they're not building dams that are increasing biological diversity and doing other things that dam building beavers do. And it's not because they don't know how or they haven't learned. They're just in a good spot. But when those subadults leave that area and eventually that area becomes occupied, that's when beavers start going into the tributaries. And that puts them in areas where they're more susceptible to depredation. And if they don't have escape by just going into deep water, they build dams in these areas, which creates that escape cover for them. It also, over time, they will dig canals so that they can radiate out away from those areas and still stay in water and get the forage. That's another type of construction activity that they do. And again, this is my opinion, based on my research and also what I've read from the literature, is they continue to move further up higher into the systems towards the headwaters. They can live in these areas, but it becomes more at risk for them. And so that's a lot of the times where we see more flashy dams, where there's they're building dams, but the high water from being higher in the system is reaching these dams or completely blowing them out. So that's a long answer, but I hope I answered your question.
All right, Samantha.
Thanks, Jamie, and thanks, Jimmy, for all of the great information. My curiosity was also along kind of the dam building beavers. I was wondering, you say it's in your opinion, is that a beaver behavior then that you're assigning, or is it a beaver, based on the ecology, are they just not building dams because you're researching larger streams, or are they just not building dams because they don't want to? And kind of how broad is the scope of your work? Are you looking at, a mixture of large rivers and lakes and smaller tributaries and streams, to kind of end on that opinion there of beavers choosing to build dams when they want to?
Yeah, that's a great question, Samantha, and keep me on it. I might, get off on a tangent, but I have studied beaver in a lot of different areas, several states. I have an active study right now in North Carolina, very different habitat types. There's a lot of beaver. There's still beaver though, and some build dams and some don't. I think it's kind of a combination of my opinion as a research scientist and some of the work that I've done, but also other things that I've read that really support my contention that, they build dams when they have to. But some of that's really driven by the conditions around them. Some streams and rivers where beaver can live have a velocity that's just not conducive to dam building. Or maybe the stream, the active channel is too wide for them to build a dam. So they can't. But at the same time, they don't have to. So I try not to think of or answer questions like I'm a beaver or I think like a beaver, because that's not safe. But just not only in the research that we do, but just observations of how beaver utilize these areas. They can live and do fine in areas where it's either not conducive to dam building, or again, I don't think there's any evidence to suggest that it's a learned behavior. It's commonly said that beaver are attracted to running water, but you can go notch a dam and increase flow, and you can sit there long enough, or you can go back the next day and see where that dam's been patched. So yes, the beaver can sense that, but there hasn't really been a study that has shown that a naive beaver, say a young beaver, has that ability to do that. I think it would be a wonderful behavioral study, but it's not really necessary either. I think they're born with the tools to do it, and in the situations that cause them to do it, that's when it turns that behavior on.
Okay. Yeah, I guess I was trying to tease out on whether is this your opinion or was this a scientific study you had done that gave you the conclusion that beavers don't build dams on both areas or can't or won't?
I have not done a mechanistic study to look at that, and I don't know that anyone has.
Okay, thank you.
Mhm.
Thanks, Jimmy. So we're going to put you on pause, and we're going to highlight Michael. So we're going to hear from Michael, and Michael's going to talk about beaver ecology. Oh, Bob has a question.
Yeah.
Sorry, Bob, I missed your hand. Go ahead.
I think you're muted, Bob.
You're
Hey,
on
Bob,
mute.
you're on mute, Bob. We want to hear you.
Okay, sorry. And sorry, I can't raise the magic hand other than this one because for some reason it's not on my keyboard here, whatever. But Jimmy, as I've read the historical accounts of beaver, beaver dams were almost everywhere. And so when you said the best habitat for beaver is where they don't build dams, I'm just trying to think about historically what was present in the American West as well as the American East. And one of the common feature always is they're always talking about dams. And so I don't quite relate to, I'm having a tough time trying to understand when you say best habitat for beaver is where they don't build dams. I just don't know what to do with that, I guess. I'm confused. Maybe you could explain that a bit more because, and as far as the experiment of whether or not they inherently are hardwired to build dams, there's a little interesting bit in the book Eager by Ben Goldthorpe that talks about an experiment where they actually did find out that beavers seem to be hardwired to build dams. You have the sound of running water, and they will inherently begin to put together a dam. So that experiment apparently has been done.
Bob, could you send us an experiment if you have it?
It's in the book by Ben Goldfarb. I will try and dig out the very specifics of it. Okay.
I do remember reading that, and I may be thinking of something else, but I think that was conducted like in a bathtub.
No, it was. Here's the quick and dirty of the experiment. They had beaver in an empty room. They put twigs or sticks across the floor. The only thing they changed is they added the sound of running water. And then they watched to see what happened. And what happened was these beaver began to inherently put together these sticks into a dam across the floor with no water anywhere. So, and these were beaver apparently that had never built a dam before. It was so, I mean, it's incredibly a little experiment, but it just, to me, it emphasizes that beaver do want to build dams, and the idea that the best, you said, and I tried to quote you, best habitat for beaver is where they don't build dams. And to me, I didn't understand the contradiction that I think I have with that statement. Anyhow.
Well, yeah. So again, that's my opinion, but in some places, beaver are going to be in an area where they can make choices. I was in Alaska last month, and I was watching this beaver swim across a large high lake. There was a stream going in and out of that lake, didn't have dams in it, but this beaver had a lodge, or this colony had a lodge on the lake, and they would swim across the lake, never leave the water, get their food, bring it back to their lodge. The beaver were doing fine there, and they didn't build dams on the little tributaries going in and out of the lake. Why they did that, can't say, but that colony of beaver had security from predators, and they didn't have to work as hard by building dams. If those beaver fully occupy all of that space along the bank, and individuals have to leave that because they're forced out, then those subadults are going to have to build dams in the tributaries.
So if we have more beaver, eventually we will see more dams, right?
Well, there's still going to be areas where you don't see dams, and there's still beaver that aren't building dams. Yeah, and to the historical references too, I just want to remind everyone, a lot of what we see varies with location too. The highest point in Mississippi or Alabama is in the few hundred feet. The Mississippi Alluvial Valley is a huge, big, flat area that's capable of supporting thousands or tens of thousands or hundreds of thousands of beaver. Very different than a lot of the situations we're seeing, for example, here in the Coast Range of Oregon. So places are very unique.
Agreed.
Thanks, Jimmy. Thanks, Bob. Stan, you go ahead and ask your question, and then let's move to Michael to make sure that we give him the time. And then remember, we have a lot of time for discussion too with Michael and after both presentations. Go ahead, Stan.
So I just want to make a statement that more of a statement than a question, that I have eager beaver, and I really just don't think piling sticks on a hallway with turning on a tap is what I would put a lot of scientific credence into. Thank you.
Very good.
Thank you, Stan. All right, let's hear from Michael.
Just want to say for the record, I'm happy to listen to more questions. So it's quite enjoyable.
We want to go ahead and give you your time, and we are talking about habitat more, so I think that's kind of more in your wheelhouse. And Bob and Stan just walked away, but remember to go ahead and mute yourself when you're not speaking, so that way we can cut down on background noise. Great.
Okay, so
go ahead, Michael.
Yeah, let's see if we can do this. If there's a little techno challenge, you'll know in a minute.
Yeah, and be sure to introduce yourself a little bit more and let us know who you are and all that good stuff.
Okay. All right. I will assume everybody can hear me okay. My name's Michael Pollock. I work for NOAA Fisheries at the Northwest Fisheries Science Center. And I've had the fun of studying beaver one way or another for a good couple decade and a half, 2 decades and a half now, 25 years, quarter century. It's really great to see people like Bob Beshta and Wayne Elmore here. A lot of their work that I read really inspired me and really helped sort of frame my thinking about beaver and what they do on the landscape. And so I just want to acknowledge that they're real, in my view, real intellectual giants and just a ongoing source of inspiration. And it's good to see them here. It shows there's life after retirement. So my title here is about beaver, but it's really in the context of my job, it's about beaver and salmon. As part of the watershed program at the Science Center, we're really tasked with, and being part of NOAA, really tasked with the recovery of salmon that are listed under the Endangered Species Act. So we're kind of, even though I'm part of NOAA, which is the Oceanic and Atmospheric Administration, we're kind of a freshwater group that deals with salmon habitat recovery. So anyway, I want to kind of take a look at the big picture here before we get too far along, which is that we are facing and acknowledge the climate change that we're facing, and that looking at the models, that it may very soon take us outside the beaver and salmon evolutionary thermal window. Salmon or Salmonidae and castor species have both been around about the same amount of time, going back to the Eocene. And what we're seeing in terms of climate change is the potential in the next couple of centuries for us to actually go outside the thermal window in which they've evolved. Pretty interesting. And it's just a reminder that what we are doing today in terms of our carbon emissions are going to impact the centuries to come, and that will be the habitat under which beaver and salmon can exist and other species. And it's just worthwhile to think about that time frame, because 150 years ago, as I'm going to talk about, people were making changes to the landscape that are similarly impacting us today, and there's a legacy left with it. So anyway, a lot here, and but those are the main points. And then, yeah, in terms of climate change, again, on the Coast Range, well, what are we expecting? Sort of in brief terms, we're expecting it to be hotter. We're expecting more fires. We're expecting less snowfall, more rainfall, more flooding in winter, lower stream flow in summer. Sorry, a little comma error there. And then significant vegetation changes, and specifically conversion to subtropical mixed forest along the Coast Range. Different models have different outputs, but if you look to the lower left, you see 2 different models. And the light green is subtropical mixed forest, and depending on what the model's outputs are, but it's a fairly short time frame. I mean, I might still be alive in 2070, excuse me. And so we're not talking about very far off in the future. And then, whoops, excuse me. And then similarly to the right, in terms of the fire frequency anticipation, we're expecting to see a pretty significant increase in fire frequency as well in a fairly short time frame. So these changes are happening, they're fairly significant, and they're fairly soon. So just with that in mind, I want to step back a little bit and just kind of talk about how long beaver have been around, and beaver and salmon. They first appear in the fossil record about 30 million years ago, and modern castor and Oncorhynchus species appear about 3 to 8 million years ago. The first beaver ponds that we see are in the Pliocene around 3 to 5 million years ago. But then there's also genetic evidence that castor fiber, the Eurasian beaver and Castor canadensis diverged around 7.5 million years ago, and both are dam builders. So there's evidence that beaver have been around building dams for quite some time, and that salmon have evolved in the presence of beaver dam. Just for fun here, just to remind people that there's been a number of species in the past. Generally, species have been larger than they are today, and we've gone through a few iterations of both beaver and salmon. So the reason I talk about, and it's worth thinking about that length of time, is because when we look to ecosystem management and what we've done on the landscape and what beaver have done, and in terms of sort of managing a landscape sustainable in the context of some of the effects that beaver have, they have a lot more experience than we do. They've got about 5 million years of building dams, for example. We have about 5,000 years. Similarly, canal building and navigating, they have about 5 million years, and again, we have about 5,000. And the nature of these are significantly different in terms of ecosystem impacts. And then stream restoration, we've been at it for about 100 years. Again, they've been at it for about 5 million years. It's a little tongue in cheek, but the point is that they have been, in effect, managing landscapes and watersheds for a much longer time frame. And as I've said, the results are considerably different in terms of outcomes. One thing that they really are not very good at that we're quite good at is drainage experience. And we're quite good at draining landscapes and lowering water tables. And to the left, you can see that's the San Francisco or Sacramento San Joaquin Delta, and just an incredible network of drainage tiles and drainage ditches. And then there's a shot it's out of Iowa, just showing the density, and really just an amazingly robust effort across our country and other countries to drain the landscape, to lower water tables. So a nod to us for that. Then the other thing we've done, of course, is eliminate the competition for space. And so there's about a 300-year history in the United States of beaver extirpation. There's a couple good books you can read, but they were essentially a kind of a form of gold or a form of currency, and so quite valuable. And that led to their rapid extirpation. But that sort of was just the warm up in terms of the Oregon Coast Range. The other thing that happened that was fairly significant was splash damming and logging in general. And I just want to give everyone a minute to read these quotes to give you some sense. And as we're doing that, there's an example of a splash dam. And then on the right is a map showing a sort of updated map showing where all the splash dams occurred and the log drives that occurred, the documented ones in the Oregon Coast Range. And then keeping in mind that a lot of the smaller streams where they were driving cedar bolts, that is, they're smaller logs that were up in the headwaters, there was also some minor splash damming there that wasn't, that doesn't show up on these things. So, and then the effect of all of that was not just the damming itself, but the flushing of a tremendous amount of sediment out into estuaries. And there's a couple documented cases there. So there's been a significant change, and that's really severely more so, I think, than the trapping itself, I think tremendously impacted beaver habitat or beaver habitat potential in the Coast Range and elsewhere. So then the other noteworthy thing about the Coast Range is that there's fairly high sediment production, and that's a combination of the fact that we have marine sedimentary rocks, as you can see on the diagram on the right, just tremendous amount of it with some basalt islands in there, but primarily pretty erosive marine sedimentary rocks. And then it's an area of uplift, reasonably robust uplift. And then we have high precipitation, and that all conspires to create a lot of sediment in the system. And The interesting thing about it, though, is you would think with all that you wouldn't have incision if we're producing all the sediment, but because of the splash damming and beaver dam removal and general, the splash damming in particular just removed so many obstructions, so there was no obstacles to flow and the sediment transport processes. So this is here is a map, kind of a GIS shot where we used actually my office mate, he's now gone, Colin, did a LiDAR relative elevation model, to identify current and historic floodplain areas. In this example, in the Siletz River Basin. And what was found, the study cited show evidence of recent historic, that is less than 200-year-old incision. It's fairly widespread in the Oregon Coast Range. Many stream adjacent terraces currently less than 5 meters in height above the current stream bed are less than 200 years old. And then in general, terraces that are 6 meters above the stream bed are generally Holocene terraces, that is older than that. And sort of any incision that occurred from those or down cutting occurred prior really to this kind of European occupation of this country, of this area. And then just, so we don't feel bad that Oregon did something really wrong. Globally, incision and drainage has significantly affected the hydrologic cycle. Just some numbers here to give you a sense of it, but if you assume a 3-meter drainage of arable lands, which are about 12% of the global land surface, that equals about a third, in rough numbers, of the global discharge that we see. And so this incision it's not a minor problem. It's not really recognized to the extent I think it should be. I think it's just a growing awareness, but that we, in the process of lowering water tables for a variety of purposes, we've really drained the landscape, and we've done there's a significant alteration of the capacity of the land to store water and the elevation at which the water is stored relative to the valley floors and such. So I think about beaver management, especially in the Coast Range, in terms of watershed processes. And so I kind of reframe the question here. And I think about really in terms of managing Oregon Coast Range watersheds, that really requires managing sediment. And I think about beaver as more of a sediment management issue. As I mentioned, the geology favors high erosion rates. Recent land use activities have both increased erosion rates and increased sediment transport rates. The net effect is disconnected floodplains, stream incision, water table lowering, and sediment accumulation in the estuaries and export to the ocean. And then climate change will likely increase erosion rates, increase winter floods, increase summer stream temperatures, and reduce summer flows. Interestingly, in terms of climate change modeling, there's not a tremendous amount that I've seen about what it's going to do to sediment transport in fluvial systems, but you can kind of infer based on the expected changes what's likely to happen. This is a little diagram just to as a reminder. This is from our 2014 paper, bioscience paper, that natural recovery from incision can take centuries. And if you kind of cycle through it, there's a logarithmic scale on the outside. But what you see is that if you're in a kind of dynamic equilibrium up in the top, you can have, from land use perturbations or even climate change, you can have fairly rapid incision on the scale of 10 to the 0 years, and then a widening process. And again, this is broad brushing it, but widening that takes years to decades. And then aggregation can take decades to century. And then you see from the record that a dynamic equilibrium, where a system can exist as a multi-channel state, a single channel state, or you can have altogether channel extinguishment. That can exist in dynamic equilibrium for centuries to millennia. We looked at, again, from the 2014 paper and a lot of subsequent research with Chris Jordan, who is also here today, and others, doing work in Bridge Creek in Eastern Oregon. We kind of hypothesized that beaver dams and beaver dam analogs could reduce recovery rates by 1 to 2 orders of magnitude. That is, we could get recovery and reconnection of floodplains in sort of years to decades instead of decades to centuries. And this is just a little diagram that I think most of you've probably seen, just showing kind of how it works with beaver in terms of their rebuilding process, that it's not a smooth linear function, but they go through cycles, and there's a widening phase. B is particularly notable up here in the right because the you have stream unit power issues, which is the sort of the ability of a stream to erode and damage a beaver dam in the context of this conversation. That's the way to think about it. And so you need a certain amount of incised channel or incision trench widening before there's enough stability for the beaver dam to withstand flows. And so we kind of recognize this, and what we did is take an approach to say, well, maybe we could reinforce some of these dams in the incision trench, and maybe we could incentivize beaver to build dams in the incision trench, and maybe they would last longer. And so we developed what are called beaver dam analogs, but in layman's terms are just pounding posts across a stream bed and then weaving, kind of making a fake beaver dam, or reinforcing an abandoned dam, or reinforcing an existing dam. But the overall effect is that we see slow reconnectivity, or in some cases rather rapid reconnectivity at the floodplain, the stream with the floodplain. The problem with this is that there's a large, with this kind of approach or to restoration using beaver, so it's a huge overlap between beaver and salmon and people habitat. And the beaver and people habitat is in conflict. This is an example from the Snohomish River, Washington, where we looked at where beaver were and the potential for beaver. And what you can see, the land use code 1 is suburban areas, and then land use code 3 is agriculture. And it's up in the upper right without the intrinsic potential model there. But what we found was that the highest intrinsic potential, that is where beaver were most likely to build dams, was pretty well correlated with agriculture and sort of suburban or development. And then when you got into, well, national forest lands, really the terrain started getting steeper, and you tended to have a lot less potential habitat there, or even actual beaver dams. So, and this is just for those of you that don't know, this is on the coast of Washington, just north of Seattle, and that's Lake Washington there on the right, but just to give you some perspective.
Hey, Michael, can you go back to that slide just for a minute?
Yeah.
So can you remind us, you said land use code, the pink is what?
That's kind of suburban development, housing, and then number 3 is, if you look in the upper right, this is agriculture, and really the key thing is the ag lands. But you can see up the river valleys, the North Fork and the South Fork, that you just, I mean, it's not a particularly unusual pattern. You have most of the development following along the flat, fertile valley floors.
And the federal land is primarily the mountainous.
Yeah, the federal lands, all the green that you see, and again in the upper right, that's the 6 is, I think, wilderness and conservation lands, but 5 is mostly federal lands, and then the lighter green, or excuse me, 4, and then the lighter green is private timberlands mostly. So.
Okay, thank you.
Yeah, sure. No, thanks for asking. And then in terms of intrinsic potential, 3 is good beaver habitat, and 0 is not so good. There's no potential whatsoever. So this is the data from the actual beaver dam locations that we found. There was, I think, about 200 dams we were able to identify and then measure the valley width, the bankful width, and then the slope. And what you see here, the lines is the average within the standard deviation. And the standard deviation is of course, approximately where 2/3 of the data are found. And so what you see here really, just to summarize, well, what you have on the, on the y-axis is valley width, and then on the x-axis is either bankful width or slope. And what we really found was that again, the majority of beaver dams were found in valleys that were greater than 30 meters, less than 8 meters bankful width, and then less than 4 degrees slope, 4% slope, sorry, not degrees. So that kind of gives a pretty good framework. That doesn't mean that all of them, again, there's roughly 1/3 that are outside these parameters, but if you kind of want to say, where would you expect to find the majority of beaver dams? This is, again, in a coastal stream. This is what we found, a fairly large watershed. And then one of the things I just want to point out is this, well, why do we care about beaver, or why does NOAA Fisheries care? And there's been a number of studies, Beachy to the right, and then to the left is me summarizing all the studies I could to look at where coho, overwinter survival studies of coho. And so each location identifier represents a location, and then there's several studies, sometimes one or more studies associated with each one. And then the overwinter, so each dot is an actual different year. So some studies have more than 1 year. And what you see is that the overall survival, high survival, are pretty consistently good in ponds, in side channels, in streams with a pond nearby, streams with complex structures, and then streams in old growth do pretty good. And it bounces around, and a lot of the variation is due to the flow. So a big flood year can be bad no matter what. And then there's a lot of variation, and these are different studies. But what we see pretty consistently is streams that are structurally simplified by logging, in general, do not do very well. And sort of the worst year in a pond is about as good as the best year in a structurally simplified stream. So, and then to the right, we see, in terms of, again, the Stillaguamish and Skagit, which are 2 watersheds to the north of the Snohomish that I just showed you, was that the loss of habitat, historic versus current, the biggest loss of habitat that we saw in terms of smolt potential was the loss of ponds, particularly in the Stillaguamish due to its sort of geomorphic condition, but fairly high. Whereas the loss of tributary habitat or main stem habitat, it hasn't changed that much in terms of potential. But sloughs here on the lower left, distributary sloughs, side channel sloughs, those have taken a pretty big hit. In general, though, for coho, and of course in Oregon, coastal Oregon, that's a species of great concern, that a lot of the survival and recovery is going to depend on how much slow water habitat we can create. And of course, beaver do a magnificent job doing that. Talk a little bit about beaver dams and beaver dam analogs as restoration tools. Here's some examples. Since it was brought up, I actually conveniently, this image on the lower left is from Bridge Creek. And there's a question coming up of, do beaver build dams intrinsically or naturally? Well, this one on the, this was one of our first ones when we were kind of experimenting around with the posts. And we put the posts in, and we figured out exactly where they should go and where the beaver were going to like it best, and where we thought it would emulate a beaver dam the best. Well, we put this in, and then for some reason we had to go and leave for a week, and before we could get going, field crews and such, scheduling. Well, we came back, and this is what it looked like, and the beaver had taken these posts and had built a dam. It was pretty exciting because in this stretch, it was about a 10, 15 kilometer stretch, we had not seen any dam building activity, but we had seen lots of beaver activity. So we knew we were in the area, they were in the area, we put the posts in that triggered this behavior, and it's kind of a auspicious sign that we were on the right track, and the rest, as they say, is history and peer-reviewed journals. This is some of the data just to show what happened. There's a study that we did about Ballas Weber, others. There's been a number of studies on this now, publications. But what we saw is that once we started doing widespread implementation of beaver dam analogs, we just sort of after a brief lag, we saw a real spike in beaver dam activity in the whole area. We set up 4 treatment reaches, and we had 4 control reaches, and the project was very successful. The treatment reaches started to see a lot of beaver dams, but we also saw beaver dams throughout the area. So we kind of hit a critical mass, and in a lot of the treatment reaches, we started seeing colonization too. So we sort of saw this rapid expansion all of a sudden. It just took off and skyrocketed. Prior to that, this is just to show, this is from Rick Demmer and Bob Beshta had been monitoring beaver dams on this, or really Rick had been doing the field work, monitoring the beaver dams and exactly where they were on the same stretch. And prior to the BDA, what we were seeing is that the dams were getting blown out pretty much every year, sometimes in 6 months. Rick was doing some surveys twice a year, and they just wouldn't last, except during low flow years, which is shown here. There's a nice peak there in about 1994, I think. So, and this is just a shot of one of our reaches. This is Lower Owens, just kind of showing what it looked like before and after. Most of the flooding is really beaver dams themselves. The beaver dam analogs just kind of kick-started it, but then the beaver took over. And then here's another example in terms of a project up in Triple Creek, Washington. Got a lot of reed canary grass, so in that regard, not unlike a lot of the Oregon Coast Range. But we put in, this team put in some of these, and what you can see is it was in size. We got some high flows, and then the next spring, there was a tremendous amount of aggradation, and we bumped the royal, we bumped up the sediment, or excuse me, the bed up, so that the floodplain was much more connected. And that project's ongoing. So pretty rapid response, geologically speaking, very instantaneous. And then just to point out that it's not just BDAs, but just the introduction of beaver in the Skykomish River. There was a 3-foot dam. This is from Ben Dickbrenner. A 3-foot dam constructed, and the lake area at this site increased to 8.9 acre feet, storing about 25 acre feet of water. And it was a single dam, and it converted a seasonal stream below to a perennial reach. So there we go. Sorry, a little graphic. So it kind of recently, Damian Ciotti from the U.S. Fish and Wildlife Service down in California, and Matt Condolf and some others, and myself included, put together a paper that it just came out in Bioscience, and really tried to formalize the approach to a process-based restoration approach that uses beaver and other natural materials. But the idea of really being to contrast it with form-based restoration. Not, you can read the paper, and I think it's a fun read. But the short of it is, what we really saw was that a lot of form-based restoration, if you go down to D on both of them, that in a lot of cases they formed equilibrium channels where sediment input equals sediment output, and the discharge in equal the discharge out. There's a number of other things that are different, but what we really were focusing on with process-based restoration, and particular with beaver, is creating a retentive landscape where the sediment that's going into a system is greater than the sediment going out, and that the discharge going in is greater than the discharge going out. So we're retaining sediment, we're retaining water on the landscape, we're retaining organic material. And then there's been a number of publications. Here's some of them. Joe Wheaton group put out low-tech process-based restoration. It's really good. Steve Yoakum put out guidance for stream restoration. We put out our own version, Beaver Restoration Guidebook. And then just a number of great publications out there if you're interested in this. Okay, so just a couple of mop-up things. The question came up is, why don't beaver build dams in hydrogeomorphically suitable but unoccupied habitat? And there's the answer is well, we don't always know, but reasons that might include a decrease in food supply, in part due to invasion of less edible species such as conifers, reed canary grass, even alder, increased predator populations or increased vulnerability to predators, other physical constraints such as excessive unit stream power or incision or unsuitable bank materials, or something we don't think about a lot, but a loss of legacy beaver infrastructure. And that is really related to sort of these observations that where beaver like to go is where beaver have been. And if you look at a site where beaver have been, especially after it's been abandoned, but you'll see our tunnels, you'll see structure, you'll see lodging structure, you'll see buried wood, you'll see kind of a lot of what we're again called beaver infrastructure that makes it a lot easier for canals and such, and it makes it a lot easier for a beaver to recolonize that. And so if beaver have been extirpated from a place for a long time, a lot of that infrastructure disappears or degrades, and so it's no longer as attractive. It's what, at least anecdotally, is what it appears. Another thing that we don't know much about is disease. We know that it occurs in a number of species and it can affect populations, but we don't really have a good handle on that. But from what I know, it doesn't appear to be a major factor. And then there's always a combination of factors. That's typically what it is. And then I just want to point out again that often many of these problems are synergistically related to incision, which is itself related to sediment management. And I really, the longer I'm in this, the more I think of beaver habitat management as sediment management, pretty synonymous. And things like the loss of food supply, that's related in many cases, and especially in the Coast Range, to incision, because we just don't have the hydrologic or hydrogeomorphic conditions to support the species that beaver prefer. So, and this is to the right, you can see that there has been a decline in the Oregon Coast Range in terms of beaver in terms of beaver pool habitat, along with backwater habitat. So a somewhat alarming decrease in it. And people have been asking about, well, what are the reasons for? And I don't know the answer, but here are some of the reasons that we see. And then another kind of mop-up thing is really this question. This came up in terms of science and how we use science to make decision-making. And I just wanted to kind of make a pitch for something that we've done in terms of defining critical areas in Washington, which is we formalized what we meant by best available science, and then we required the use of it for certain things. So this is in our legislative Washington Administrative Code, and it kind of outlines it. And so it's a way, it's sort of, I guess, dispute resolution to say, well, which information or what data is more reliable, and how do you weigh it, and how do you weigh expert opinion versus a model or something like that. So this is just kind of some guidance that helps, and in our case, it has the force of law, and it's pretty similar to federal decision making that there's been, and at least in the courts, sort of requirement to use it, because otherwise you face an arbitrary and capricious standard, and that has led to people having to have a rational reason for that is management agencies to have a rationale for what they did in terms of their science, in terms of a management decision, excuse me, and then they've had to rely on science to do that. So it has to be backed up by science. So And then just the last thing is that, especially with climate change, when we have large scale problems, they require large scale solutions. And there's some really nice examples globally where this is happening. The Loess Plateau in China, tremendous amount of restoration, taking really arid areas and making them fairly verdant again. And this is an area I think the size of Belgium, so it's not insignificant. And actually changing weather. And then the Sinai in Egypt, they're actually modeling, and there's this group called the Weather Makers that are proposing to green it and modeling to see whether they can actually change the weather patterns enough and get a positive feedback that creates the precipitation that will sustain a much more robust and greener landscape. So, and I just mentioned that I say, for us to do it in the United States, we got to cut through the green tape, the regulatory process. There's a lot of other countries that are doing this, that are really engaging in these massive restoration projects, and the U.S. is falling behind, and some of it is the regulatory challenges that we face, among others. That's not the only thing, but so finally, in summary, I would say that in general terms, the basic difference between humans and beavers across landscapes is that beaver have been raising water tables and decreasing sediment transport rate, whereas humans have been lowering water tables and increasing sediment transport rates. Beaver activity tends to retain sediment, water, and organic material on the landscape, whereas human activity tends to export these materials. Beaver managed salmon habitat for millions of generations with generally positive results. We haven't been quite so good in our management. And then until recently, beaver and human management objectives have been mostly in opposition to each other, starting to change now with groups like this and elsewhere. So the last slide is really turning the tables a bit, because there are policymakers here. And in terms of beaver-related policy and management questions, I think these are the ones that really come to mind for the Oregon Coast Range, and I think we need to think about. And that is where do we want to store our fluvial transported sediment? Where do we want our sediment to go? The floodplain, the estuary, or the ocean? Okay, right now it's pretty much going to the estuary, and what didn't go to the estuary, to the ocean, and what didn't go there went to the estuaries. So my vote is the floodplain. So here I'll answer these questions for you. Do we want to reconnect our floodplains, that is, undrain the landscape, consistent with salmon recovery objectives? I would say yes. Noah would say yes. Where do we want the water table elevation and river valley bottoms? I would say near the surface. Do we want to manage water and sediment on a watershed scale or by landowner type? I would say the former. Do we want to manage watersheds in anticipation of predicted and inferred climate change effects on vegetation, hydrology, and sediment transport processes? I would say yes. Do we want or need beaver dams and beaver restoration to play a role in support of meeting any of these objectives? I think so, but I think that's for this group to decide. Can we meet these objectives without beaver dams or beaver restoration? If we choose these as objectives, I don't think we can, but again, that's a question to ask the policy people. Do we want to try different approaches in different coastal range watersheds? That is, do we want to think about trying different things and experimenting? I think it's a good idea, but that again is a policy decision. And then the last, do we want to formalize the use of best available science to guide decision making? We kind of have in some extent. In this group, there seems to be a movement towards that, but I think formalizing it has some advantages because it's really a sort of a dispute resolution process, and I think it's a good thing. So, so I'm going to leave these questions up there for the policymakers in this group to think about a little bit, and I'm happy to answer questions or engage in a dialogue.
Thank you, Michael. So here's what I suggest. So we're at 5 minutes to 4. Why don't we take just like a 10-minute break, because we've been sitting here for 2 hours, come back, and then we'll engage in dialogue with Michael and with Jimmy as well, and just have a much bigger conversation. So I think just a little break would help me, biological break, get a glass of water. We'll come back a little bit refreshed and be able to focus on Michael and Jimmy and each other. Does that sound good? Okay, so 10 minutes, just a few minutes after 4, we'll come back. 5 after 4. All right, we've got about 1 more minute. And to our viewing public, thank you for your patience. I hope you all took a 10-minute break as well. We will start again with our group here in just about a minute. I see we've got a couple folks with their hands up. If other people want to get in the queue, now's our time to Bob. Okay, so I've got Jefferson, Stan, and Bob. Those will be our first 3. I'll have Jefferson, Stan, Bob, and Brian. And Bob, sometimes the raise hand function is if you open the participants list, if you open that, sometimes you can raise your hand as a part of that. There's like a few dots.
If I open what?
The participants, if you go down to the bottom of your screen, you'll
Yes.
see participants. Sometimes the hand can be there. Anyway, just troubleshooting a little bit.
Nope, I don't see it.
Okay.
I used to have it. I don't know why it's gone.
In reactions now, Jamie and Bob. Under
reactions.
Raise hand should be on there.
Yep, I
Got
see
it.
it online. Yeah.
Thank you.
Good job. Thank you, Samantha. And if some people have an iPad, it's a weird interface too with an iPad. But anyway, all right. So we're all back. People are turning their videos back on. We've got remember to mute yourself when you're not speaking. And we've got there's Bob's hand up. That's a clapping hand, Bob. But we know.
Okay, I'm working on it. Hang on.
Yep. There, you had it up there. You did have you had a clapping hand, but then you had your regular hand.
All right, I got it. Thank you.
You got it. There you go. All
Big
right.
Big learning.
So just so we can manage our time, we have probably about 5 minutes of wrap up that I would like to do with all of you, and so that gives us a good 55 minutes or so, 45 minutes of time with our speakers. Thank you again to Jimmy and Michael. And we've got all folks with their hands in the queue, and we'll just start with Jefferson, and it'll be Jefferson, Stan, and then I'm going to jump down to Bob because he did have his hand physically raised, and then I'll jump back up to Brian and Danielle and Leland. All right, Jefferson, start us off.
Thanks for that, Michael, and Jimmy as well. Again, it's interesting to hear when you showed the aquatic inventory data of the decline in dams, and to think about your statement that beaver make dams where they had made dams before, like that draws them to a place. Previous beaver activity draws them to a place. But if beaver dams are declining, then not only are there fewer places where you could then go see a beaver dam and then cue them to that, but then also that the loss of beaver dams apparently creates stream conditions with more power or less water, that sort of things, that hydrology and physics that would make it so it would be harder for beavers to make dams. So it's kind of just does it make sense based on those things that one, that loss of beavers could contribute to loss of beavers, and then also based on what you were saying with the Bridge Creek restoration work, is that once you get down to a kind of a not a beavery situation there, that it is at least inherently reversible if you just figure out what the limiting factor is at that that point, even as places that looked as lost as Bridge Creek.
So I was looking for a question in there. Would you mind?
Is the loss of beaver, does loss of beavers contribute to loss of beavers? Because loss of beavers means loss of habitat, and
Yeah,
therefore
okay.
it's a self-fulfilling prophecy.
Okay, well, yeah, no, I think the point is really that when you have lost beaver and you've done to our streams, what we've done to them in terms of, in particular splash damming, just removing all the obstacles and then creating these, 100-year flood events on every time you ran a splash dam. And not only that, but it was just loaded with logs. So you've just got this tumbling machine moving through these systems, taking out any sort of semblance of habitat complexity, including a lot of what beaver used to do there in terms of the infrastructure they put in place. And the point is that it is going to be harder for beaver to reoccupy that areas when you've just so radically altered it and changed and removed all of the elements that they need and utilize to be successful colony. So if we had just gone in and trapped out the beaver and then left, they would have. We would see a quick population rebound, which is, as us pointed out, and in places where there hasn't been quite so drastic a change in the conditions, in particular where there hasn't been incision, it can be a fairly quick rebound, even if there's been a heavy trapping pressure. But where we've just totally altered the habitat and taken out, again, the infrastructure needed, what I call it the biohydrogeomorphic infrastructure, I think that they're going to need assistance. And our data, the studies that we've done, the restoration we found has found that when we provide them with a lift, when we give them some structure, when we give them something to build dams off of, they respond to that, and then we do see them forming these. We don't know exactly. It's not like we monitored the population and figured out exactly what they did, but in general, when we started adding artificial complexity, the beaver responded, and they used that. They used our structures, and then they built their own, and the structures we built helped to lower the stream unit power. That is the potential for the water to remove beaver dams and scour them out. And they started building more dams, and the population started expanding, and we've got the opposite of what you're talking about. More beaver created more beaver, and the population expanded, and we created the habitat complexity. So, complexity begets complexity, simplification begets simplification. So the question is, how do we shift it? If we want beaver on the landscape, how do we shift it? What do we need to do as managers that are working cooperatively with beaver now? What do we have to do to sort of incentivize them and get them back in places where they historically existed but don't really exist at the level or with the dam density that they existed historically? I hope that answered the question.
Just
please.
real quickly, that the point was that when we look at studies of where beavers have been trapped and then they move in quickly, like in the Tennessee study, if the habitat itself wasn't impacted, it might be a very different result than what happens in Oregon, or vice versa. And so that you have to look at the habitat quality when interpreting that.
Yeah, here's another example, even outside of a splash damming, is that if you remove beaver from a place for a long time, like in the Sierra, we've seen a significant conifer encroachment into wet meadows. Okay, the lowering of the water table changes the vegetation. There's no longer the species there. There's no longer the willow. Grazing may have eliminated the willow too, and the combination of factors. And so that's an example where you've lost the food source due to land use changes, maybe a little incision in there. And so you have these changes that have occurred because the beaver have been absent. And so, conifers coming in, if the beaver were there flooding the land, you wouldn't see that. And in places where we start to see beaver coming in again for one reason or another, or we've helped given them assist, we're flooding the conifer, we're seeing the conifers flooded out and kind of this wet meadow reestablished. So
Okay, thanks, you guys. And just a word, so we've got 1, 2, 3, 4, 5, 6 people with their hands up. If everybody takes 5 minutes to have an exchange with our guests, that takes us to about 35 minutes. So just, keep that in mind. Stan, go ahead.
Thank you, Mr. Pollack. It was very enlightening and interesting. I've asked this question of NOAA representatives several times before, and it really gets to the bottom, I think, of a lot of what our discussion's revolving around. But can you explain NOAA's position on Oregon's current beaver harvest management program?
I'm sorry, what was the question?
Can you explain what NOAA's position is on Oregon's current beaver harvest management program?
I'm not in a position to answer that. That's a policy question. I'm a scientist, so I cannot answer that, and it wouldn't be appropriate for me to. I can certainly refer you to the people that do make those decisions, but I just inform policy. I don't make it.
I would really appreciate it that referral can be made, because I have asked that question of Dr. Jordan and Lance Kruzik, who've been involved in the beaver question in Oregon, and tried to get an answer to that. So if you could send me an email, or I can shoot you one and get me in the right connection with the right person, that'd be great.
Okay, absolutely. Yeah, please send me an email and ask the question, and I will get you an answer. Okay.
Thank you. Thank you very much. And then I have a couple others here. So what do you think, in your professional opinion, what the current Oregon program is having on salmon recovery? In other words, regulated beaver harvest, what impact is it having on Oregon salmon recovery programs, coastal, coho specific?
Yeah, I mean, that's a good question. The short answer is I don't know, because we don't have a lot of data. What I went through was really an effort to explain there's been so many significant land use changes that we really, as I said, it's about sediment management. And so if you're really talking about how we're going to manage these systems, you really have to look at what you're doing with your sediment. And in particular, whether you want to start creating conditions that allow sediment to accumulate in these incision trenches, and whether you want to allow it to start dispersing on the floodplain. To me, if you want beaver on the landscape, you need to look at that. You need to look at that because that's going to have hydrologic effects and affect the local hydrology in terms of raising and elevating water tables, and in terms of inundation frequency and things like that. To me, that is much more important to focus on. And if there's not good habitat out there, the beaver, it's going to be a struggle. But having said that, beaver will recover over time. They will recover habitat over time. But we just haven't seen it, if left to their own devices, if they weren't trapped, for example. With Bridge Creek, we did see recovery, and in part, I believe that's because it was a protected area. So I think it's a complicated question, but I think that you need to look at there's multiple reasons why beaver aren't recolonizing the landscape, and we need to look at all of them. That's just one factor, and it's very, very difficult to assign a specific quantitative role to each of these, especially because they work synergistically.
Thank you. And so, and I really agree that the altered habitat appears to be the most limiting factor. If we were to have a 1 to 5 scale for beaver repollination or viability, long-term benefits, it's going to really be most beneficial to have beaver on those habitats that can allow beaver to be there, correct? I mean, alluvial, flat, the plains, what I'm seeing here, and another question I had was on the Skykomish, and then the other stream that you mentioned in Oregon. Incidentally, was that in Mount St. Helens runoff stream there that we saw the sediment picture on? It's not. So where I'm going is it appears that we could be having harvest on some of the highest quality habitat and maybe limiting harvest on some of the lowest quality habitat? I mean, I'm just trying to say what's going on.
Yeah, well, I think you have to look at dispersal, and Jimmy talked about that. So if you had let me kind of answer it indirectly, because first of all, we don't know, and we have to make decisions with an inexact science, with the best available science. And so I think you could answer that question in part by what I put as a policy question of is, do we want to have different approaches in different watersheds? And you can set some watersheds aside and say, we're not going to trap here. We're going to trap at other places. There's predator issues that you could deal with differently in different watersheds. So you could take an approach of sort of one of ignorance and say, we don't know the answer, but we're going to try to acquire knowledge to understand what works and what doesn't work. And you might find that a cessation of trapping versus some sort of limited trapping, that there was no significant difference in terms of rates of recovery. You don't know. We're not going to know until we try different things. So we can sit here all day and talk about what's the best approach, but the fact is we don't know. I always encourage, I'm a scientist by nature, I always encourage, let's try things and see if we can figure out what works. And don't be afraid to try something else if what we did doesn't work.
Thank you for your time. I don't want to filibuster for everybody. I have dozens of questions. I mean, dozens.
Any of you are welcome to follow up with me via email. Happy to talk about this more. So
thank you so much, sir.
Thanks for your self-restraint, Stan. Let's see, Brian.
Hi, Dr. Pollack. Thanks for the presentation. I think you might have alluded to an answer to my question, but your work on Bridge Creek, as I understand it, you put in some artificial or beaver dam analogs, I guess they're called, and that was in addition to affecting the hydrology themselves to get beaver to start to build more beaver dams in the stream. And I'm wondering, were there other policy changes to sort of help all that take hold, and how did those play in? And I think you alluded to the fact that there was a closure there on, I guess, hunting and trapping, and how did that factor in? I'm just curious about your were there other management changes, and how did those play into your work and the results?
Yeah, that was actually a constant. It just happened to be that beaver were the trapping wasn't allowed. I think that was Rick Demmer, when he was working for BLM, had facilitated that. So that wasn't a variable. That was a constant. We didn't experiment with that. And then in terms of other land use changes, and again, there wasn't any real changes, but there was notably land that was owned by BLM, the federal government, and that's really, and the Park Service, Painted Hills National Monument. And these areas form kind of the basis for us to be able to prioritize beaver restoration in these areas. But yeah, there wasn't really any sort of regulatory changes that significant. I mean, gratefully, because I would screw things up. So it really was about the physical changes in the response to the beaver. And
Hey, Michael, just to add to that, and correct me if I'm wrong, but there was a large land acquisition by the Park Service and BLM at some point. And Bob, you may know this, like the mid 80s or something. And at that time, grazing was significantly reduced on the federal lands there. So that was kind of a programmatic change to how things were managed. There's still those interstitial ranches within the 35-kilometer section that you weren't able to get into and we weren't able to get into, but grazing went down to almost zero on the public land, I think.
Yeah, that's right. I mean, there were some changes and there was recovery, and I don't want to say that what we did was what caused all the recovery. So there was a slow recovery, and in fact, BLM, there was a fairly vigorous debate because there were people that said, well, let's just let it recover naturally. And we kind of mapped it out though. And from NOAA's perspective, we had an ESA listed species using the habitat and said, well, the rate of natural recovery is probably going to be slower than what we want for our recovery plan. So that, but there was that dynamic tension of sort of letting that the land kill itself on its own with those land use changes from the EU. So.
Yeah, but I think Jimmy raises a good point. Had the grazing not changed on the Forest Service lands, you would have never, I think, had the opportunity to do the beaver dam analog studies, because that area had been really heavily hit by cows, and the major changes pulled the cows off for several years. And then, as I understand it, shifted to winter grazing, which has much less impact. And so you had great recovery of the willow and riparian plant communities. Beavers had entered the system, and then you got the big boost by coming in some 20 years later, let's say. And it was great what happened there, but it was set up in a way to give you that opportunity. Had you come in 20 years prior and put in beaver dam analogs, I'm not sure you'd have seen much.
Yeah, I agree. It was sort of a perfect constellation of events, and so yeah, agreed.
All right. So we're going to move on to Danielle.
Thank you. And thanks both for your presentations. So this is a question, I guess, for both of you. So this group has been charged with providing recommendations to the Fish and Wildlife Commission on beaver management in the context of climate change, fire, drought, etc. After listening to today's presentations, it definitely seems that some of the conclusions are, we don't know everything about everything. And even some of the things that some of the scientists feel quite certain about, there's another study contradicting it, which quite frankly can lead to an almost paralysis of taking action. So with that being said, I'm curious if you can speak to the role, especially in the context of climate change and beaver management, ecological resilience, that the precautionary approach or precautionary principle plays in this particular instance.
I think she's asking it of either Michael or Jimmy.
Jimmy, you want to?
I'll go first. I'll try to answer that anyway. So I agree that there's a lot of things that we don't know and we need to know more of. We do have in my lab some ongoing research. One of those is, as I mentioned, John Stevenson's a PhD student of mine now. He just finished writing the manuscript, or the lead on the manuscript, looking at water temperature and dissolved oxygen below dams. Another part of his dissertation is working on a new predictive model for beaver specific to the Umpqua River Basin in Southwest Oregon. And his third chapter is looking at some climate change scenario models and inferences fed from his predictive model for his species distribution model or habitat suitability model. I don't know what's going to come out of that. It's going to be interesting, whatever it is, but we need more of that, I think. And again, as I alluded to in my presentation, and I think you just mentioned, we do see some things that are kind of contradicting one another, but that's okay. We need to understand the whole picture and not jump to conclusions that it's going to be one way or the other. We need to weigh in all the factors. And I think one of the things that I'm excited about from this group is the recent conversation about how an end state of all of these discussions is going to be to identify some of these knowledge gaps and recommend some ways to fill that through hopefully new research and find ways to fund those studies. Michael?
Yeah, go ahead. I'll be brief. The reason I put all these policy objectives at the end is because I think your answer is guided by your policy objectives. And so I think if you can agree, at least for some of these areas, what your objectives are, it's going to guide what you want to do in terms of beaver management. There's going to be uncertainty. There's always going to be uncertainty. There's always going to be imperfect knowledge. But I think you have to make these fundamental decisions of, again, where do you want the water table? Do you like where it is right now? Do you like the riparian vegetation you have? Do you like where your sediments ending up? And so there's just these sort of fundamental questions that need to be answered, and then that will guide what you think what should be done with beaver and what role they should play. So we're never going to have all the studies, but I right now I feel pretty confident that if you as a group or whoever the people are that make these decisions, if they made these decisions in terms of answering these questions, I think pretty readily with a group of experts develop a plan for meeting those objectives using beaver. But it's not up to me to make those decisions, but I can, if you want, I can certainly guide them. And I think we have sufficient knowledge to really move forward with beaver as a restoration tool, provided we have the objectives in place.
Okay, thanks for that. All right, Leland, you're up next.
Can you hear me? Sorry.
Yeah.
Yep. Thanks. Thank you both. Pretty interesting set of presentations. There are a couple of questions which somewhat got answered around the Bridge Creek stuff. Mostly brought up from your work up in Snohomish, which identified stream flow and other variables that informed a lot of that. I'm wondering if there were kind of significant variables in that restoration work outside of just the BDAs that influence the response out there. And as part of that, you also mentioned that beaver were occupying the area. And there's been a bit of discussion, I think, across this working group and across today as well about using damming to infer an occupancy. And I was wondering if either one of you could talk about that a little bit, because that does probably influence different management options. If beaver are on the landscape and not damming, that's very different than if they're not there and then looking at relocations or other sort of efforts to recover habitat.
So I'm sorry, Leland, so what is the question in there?
So the question for you specifically is, were there other variables that influenced the beaver damming response on Bridge Creek? So you talked a little bit about grazing, but one of the highlights of your work up in Washington was about stream flow, and you didn't mention any of that with that. So I'm curious if there were other variables happening there.
Yeah, okay, yeah, I think, I mean, Bridge Creek was a stream with specific amount of stream flow in it and hydrologic characteristics. But in general with that and with numerous other studies, what I showed you from the Snohomish watershed was not unusual. It was just one example where we did a fairly detailed census or survey of beaver dam locations, but those characteristics you find elsewhere, certainly in the Intermountain West and the coast. So that's not really sort of unusual or surprising. As far as Bridge Creek itself, though, the basic experiment was to look at we took 4 reaches and we treated them with beaver dam analogs, and we looked at the response. We looked at the fish response, the vegetative response, a number of different, the thermal response, a number of different responses, and then compared it to 4 untreated reaches. And that was in our Nick Bowis was the lead author on the paper there, and you can look at all of that. So that was the comparison there. I don't know if I'm answering exactly what you're getting at, but that we tried to control as many variables as possible on the Bridge Creek so that we could look at the effect of the restoration effort itself. And that, there's always variation, but that was what we were focused on, and in particular the response of the salmonids in that system. That was our sort of the most important thing from again Noah fisheries perspective.
Sure. So the second question, which is for either one of you, was discussion around using beaver dams as to infer occupancy or population. And I was hoping one of you could respond, because that has been a source of conflict within this entire working group, I think, where people have used
sure.
those both interchangeably.
So no, that's a good question. I mean, as what's been mentioned previously, it is really hard to actually know what the historic population was or even the current population. I mean, they're a rodent and they have a number of different life history strategies, sometimes building banks, sometimes living in lakes, sometimes building dams. And so I think if you just counted dams, you would miss the total population size. In more remote areas, in the Canadian provinces, sometimes there's been aerial surveys that counted lodges to get an approximation. So anything is an approximation of the population, and I really haven't seen good data out there to say here's what we estimated using this methodology, and then here's the true population. The true population is really challenging to get at. My sense is that most population estimates based on physical things like lodges or dams are going to underestimate it, because there are so many different approaches that the beaver take to the life history of their strategies for survival.
Okay, thanks for that. So just
Can I
to try
follow
and
up on
check-
that?
Who wants to follow up? Oh, Jimmy. There you are.
Hey, thanks, Jamie. So Leland, I'm not sure if I fully understood your question, but if you see an active dam, that definitely confers occupancy in that area. But if you don't see a dam, that doesn't mean that beaver don't occupy that area. And maybe that's what you were getting to. And we have a systematic protocol that we use when we're inventorying streams for beaver. Dams is one variable. We're looking for slides and tracks and fecal material and chew sticks and food rafts and all the other beaver sign that they leave out there to document whether they occupy an area or not. Many times there are dams at those locations and we quantify those as well, but many times there are not dams. So, as we're saying, there's not really a good way to use dams as an index under canopy, using aerial photography and anything like that. If you're not walking the streams, in many cases, you don't know if beaver are there or not. And we've shared that protocol with anyone that wants it, including some of the national forests that seem pretty excited about using it. So as we talk about, any experiments in the field or case studies or research studies or anything like that, where we're looking to find an effect from something, we hope that people are going to use that so that they're looking to see if there is a response from beaver. And it is going to require some waders on the ground, so to speak, to identify that.
Yeah, I would just add, those are really good points. I was thinking about Rick Demmer's work, talking to him about, he was doing the beaver dam surveys on Bridge Creek, and even the timing of when he did it, he found if he went at certain times, the dams would be blown out, then he wouldn't see them. So we really tried to pick the time of year when there would be dams, because they're so frequently didn't survive even a year or so. So it's I think more an art than a science to figure out. But we do with that.
All right, thanks for that. I just want to so we've got 7 people with their hands up, and we have a little less than 20 minutes of time. So that means if folks can keep their question succinct, and if our guests can answer the questions just as succinctly, we'll be able to get through everybody with their hands up. Amy?
Yeah, and I'll be quick because I think it's more of a statement at this point, because these have been great presentations, so much information to try to absorb. What I'm having to kind of wrap my head around those. How do we take this information and then put it into the charge of the group? Because it seems like, a lot of what we're talking about has to do with things that would be more like on the land use side of things. And so, outside of ODFW's purview that way. And then also maybe more slanted towards private land versus federally owned land. So, while the information is wonderful and I'm kind of geeking out about it all, I have to kind of bring myself back to what do we do with all of this within the parameters of the scope and the mission that we have for the group. And so just wanted to kind of put that out there as we wrap things up and the lens that we use to apply to this information and how we go forward with it.
Yeah, I appreciate that, Amy. And if I can just answer this one. So this meeting together with the meeting at the end of the month, the one at the end of the month, we're going to be looking at federal land focus with federal land managers on case studies and management options. And so, the information you've got on the Ecology Biology 101 together with some, real life application and what people found, I think those things together will help us figure out, what are the suite of management options that we want to recommend coming out of this group. So just remember they go together. So Lauren?
Yeah, I was just going to say mine was more of a statement and very similar to Amy's on just really making sure we're staying sort of focused on the mission of this group. And I appreciate all the information for sure, but how we affect how the federal government chooses to manage their land, I think is different than how we have beaver management on their lands within our state. So I think we need to really make sure that we're not going outside of what we're trying to do, which is talk about beaver management and broaden that to land use, specifically what sort of effect we as this group has on how the federal government manages their federal lands.
Okay, thanks for that, Lauren. So I'm going to move to, hey, Bob, you had your hand up earlier and then you took it down and now it's back up and I feel like I skipped over you. So I'm going to jump to you, Bob, and then I'm going to do Brian, Chris, and Ernie. And Jefferson, I'm putting you at the end of the pack because you started us off with a queue and I want to get other people who haven't had a chance yet to get in. So Bob, go ahead.
Very quickly, I'll try and keep it brief. Michael, much appreciate your presentation. I like the big picture overview, tying in the history, tying in climate. We have major issues coming at us. And I would really wish it if you would submit your PowerPoint to the group. I could go back and look at your slides if I have to look at this presentation over and over again, but I would really like to be able to have a PowerPoint, or not the PowerPoint, but a PDF of your slides that I could just scan through, because I think there's some great ideas and great information there. Some people have indicated the science is confusing. I would argue the science is compelling. We are rapidly moving into crisis stage. We need to think about what we're going to do with our streams in the American West, across the state of Oregon, whatever, and can we recover or improve resiliency? And I'm going to go back down very quickly then to a simple question. I would like to talk more about this, but we seem to think dams and number of beaver and all that are very difficult to work around, whatever. But I would argue if you take a big picture view, dams represent a reasonable metric to assess what's going on in the landscape. That is, I can measure dams in Oregon and I can compare those to dams in Utah. And I can take dams as they exist today and I can relate them to habitat models that predict dams. So what's your sense of the dam business? Because you showed a slide, I think it was the second last one, showing the downtrend in dams in the Oregon Coast Range and said you were concerned. I'm concerned too about that data set. And as bad as it is in the Oregon Coast Range, it's worse in Eastern Oregon. So what is it about dams? Can we use them or not?
Yeah, I think the short answer is yes. And it's to use them for what? And I think it's a really much more so than an indicator of beaver population. It's an indicator of ecosystem health. So if you see dams on the landscape, if you see them in a watershed, it's a pretty good metric in terms of resiliency to climate change, in terms of resiliency to fires. We're finding more and more that where you have elevated water, it's an indicator of water table elevation. And what we're seeing in places that have been hard hit by fires, as an example, where there are beaver dams, they serve as fire breaks. They serve as refugia for both plants and animals, and they provide a basis for recolonization. So I think it's an overall indicator of the condition of your watershed or your ecosystem, and that's a great indicator for that.
Okay.
All right, next up, we've got Brian.
Hi, Michael. Question for you. I'm Brian Stobman with the Forest Service, and we are using BDAs on the National Forest, but in some cases, we're also taking a little heavier hand approach with some valley, whole valley reshaping, regrading with using the so-called stage 0 approach that Powers and others published in 2009, and Castro and Thorne have published on, as well as Ellen Wool. And I guess my question, there's a number of sites on the National Forest, particularly in Oregon. So the Whitechoose Creek site that's adjacent to the National Forest, but also some sites on the Willamette and in the Coast Range on the Siuslaw. And so my question is, do you find that those approaches to be broadly consistent with some of the goals and objectives you laid out as far as the process-based restoration you were talking about previously, and therefore conducive to beaver restoration, essentially?
Yeah, I think, everything's context specific, but I think that doing, really the stage 0 restoration or valley fill, filling in an incision trench and stuff, that's consistent. The way that it's not consistent is that it's very energy intensive and it's very costly, relative to something like beaver. But if there's the money and funds and the landowner cooperation, there's been some spectacular results with stage 0 restoration. So, but I think you need to look at everything. Some of the issues that I've seen come up are things like when the valley fill is, if the local soil is used, you potentially damage your seed bank. If you've got heavy equipment coming in there, you're potentially introducing non-native species, potentially compacting the soil, things like that. So there's just kind of some of the effects from using a lot of heavy equipment that and stuff. But it's like everything. You look at, well, what's the cost of not doing anything, and that can be quite high. And if there's momentum and enthusiasm for that, I think that it's a good thing to be doing, but then to monitor it and see what effects we get. But some of the effects I've seen have been really positive. There's been a few downsides to them, but I think overall it's been good. So
yeah, appreciate that. We are, we view it as being complementary to the BDAs and such. And as far as the costs go, they're actually cheaper than some of the more intensively engineered kind of, more traditional restoration work, number one. And number two is we do have a lot of, ongoing research, monitoring, and evaluation underway. But there's certainly more opportunity, including there's not a lot being done on quantifying beaver occupancy before and after. We have anecdotal evidence, but that's definitely an opportunity. But you answered my broad question, so I appreciate that.
Yeah, and I would just say that the stage 0, what you're doing is, again, I'm thinking of beaver as a management tool. And when you're talking about valley fill restoration, you're doing the things that I'm talking about. You're saying, you're making that policy decision, right? You want the water table up high. You want that, you want the channels to be able to move around. So you want to kind of get rid of that incision trench. So it's sort of the same. You're making those decisions. You're just using a different tool to get there.
Yeah.
And Lauren, I was just saying, Lauren did put in the chat, for those of you who can't see it, that House Bill 2298 did pass in this last legislative session, authorizing ODFW to build for BDAs on the east side. So we'll put that link in the meeting summary. Bye, Kyle. He's heading off to football practice. Chris, you're next.
Great. Thanks, Michael and Jimmy, for those presentations. As everyone said, just loaded with information that's overwhelming us all. I wanted to ask both of you a question about the large river, sort of, Jimmy, you referred to them as lazy beaver that live in the, the good living where they don't have to build dams because the water is already deep enough and they have access to food along either the large river or pond lake systems. But Michael, you showed with your Snohomish the coincidence of the high beaver intrinsic potential area with those large rivers with human land use practices that were sort of conducive, that aren't conducive to coexistence. And so I'm just wondering about, especially since we're also looking at being on federal lands, which tends to be uphill from those valley bottoms. So in general, the stream network is less of that easy living beaver habitat, but not zero. But my point is, or my question is, how you two think about this. Of the stream network, less than 1%, or maybe even 1/10 of 1% of a stream network are those large river valleys. And so therefore, even 99 and 99% and above of the river network is uphill from those large river valleys. Lots of it isn't beaver habitat, but there's so much more of it. So how do you balance those two things of the easy living in the valley bottoms versus all the rest of the river network that has patchy pocket floodplains areas in order to say, to think about beaver habitat on beaver occupancy farther uphill, maybe not in the easy living areas that the way you were talking about, Jimmy. So can both of you comment on that?
Sure, I'll take a quick. I mean, it's a good point, and I just want to clear up any confusion from when I was talking about Forest Service lands in the Snohomish watershed. That wasn't by any means to implicate that all Forest Service lands are less good than private lands. It just in that particular case, that was the pattern, and then it wasn't really the large rivers that were good habitat for beaver, because we were looking specifically at dam building potential. It was the low gradient small tributaries, of which there were numerous ones in those areas. So small tributaries crossing the large floodplains as an example. So small streams on low gradient habitat. That was the good habitat. I think in the Oregon Coast Range, I showed you that one detrended LiDAR imagery. And I think I don't know if that was actually in Forest Service land or not, but I've been around the Coast Range and driven around, and I've certainly seen a lot of habitat on federal lands, small streams with low gradient habitat that would be quite suitable, in my view, with the right sort of vegetation and such for colonization. So. And then when you get up a little higher in the watershed, you're also closer to the sediment sources. So in terms of filling in that incision trench, that's probably a pretty good place to start. And if you're thinking about how to prioritize where to focus beaver restoration, places, that's probably going to be a pretty good place. I think. And then you've also got the advantage of the Forest Service that there's not going to be necessarily competition with agricultural lands, except you do have some inholdings. So I think that those areas can be potentially pretty good with an assist to get them occupied by beaver again. So I think, in an ideal world, from a salmon habitat recovery perspective, that some of the inholdings and some of the lower gradient areas would be more available. And there are landowners that are committed to that kind of activity. I mentioned the climate change and the expected changes because what I find, frankly, in a lot of areas is that the private landowners are the most gung-ho about bringing beaver back in because it's raising water tables and sub-irrigating their crops, and so they see great benefit. So depending on whether where the best place is for beaver restoration sort of depends on I guess what the climate conditions are. And from what I'm seeing in the climate projection model, I think that if we're looking ahead, it's going to make a lot of sense for everybody in the watershed to start thinking about getting beaver back on the landscape. I see it as a win for everyone. But maybe I'm a little, I guess.
Hey, we've got Jimmy. Jimmy, did you want to say something before we hear from Ernie and Jefferson as our last two? Go
Yeah,
ahead.
just real quick, Chris, I think you need everything that you mentioned. The beaver that don't build dams, that live in large undammable areas and including lakes and sloughs and other places where they're not dam building. I think you could think of those as sources for dispersal into sink habitat or, in a metapopulation scenario. So they're important, even though they're not building the dams that you'd like to see. Just a quick comment, I was out walking part of Lobster Creek the other day, and, we found one dam that was breached and didn't look like it had any current activity, and then another dam that had some current activity on it. But in all the area that we walked, that was the only beaver sign that we found that was active. But we also found, vegetation, woody stems that were chewed on that were about 5 feet above the water. And there's no beaver that tall to chew that. So, from that they were there foraging when the water was higher. So something that I think people often overlook is that water is a big part of beaver habitat. And it's not just about the trees, the dominant tree species and the woody riparian vegetation, but beaver do move as the water rises and falls. So, that stretch that we walked, or that reach that we walked the other day, at times of the year will have more beaver in it. And it may have more dams in it, but it's not year round. So just something else to think about, especially in light of talking about suitability for beaver.
Yeah, thanks for that, Jimmy. Ernie.
Thank you. Thank you very much. I, again, appreciate your comments. I'll go very quickly. Just to summarize what I think I heard from you, from each of you. If we continue with business as usual in the state of Oregon, does the probability that we will have more beavers in the future go up or go down?
Jimmy, you want to take that and kick it over to Michael?
Yeah, Ernie, the question is, I don't think we know, but in looking at different climate models, if we have less water and streams dry quicker, beaver that are in those areas are going to fall down lower in the system, or they're going to die. So they will move to lower stretches. If we have more water and more streams fill, and we have more perennial streams and more water present, there's a possibility that we'll have natural dispersal and increased populations of beaver into these areas because there's more available to them. So it could go either way as the climate changes.
Okay, I understand that there are variations in climate, but I'm looking at business as usual for our policies with respect to beaver. And I recall seeing a graph, maybe multiple graphs, that show it's going down. And so the continuation of what we have right now, is that going to give us more beaver or less or fewer beaver? What's the probability?
Well, yeah, so we don't know the probability, but we do have the trends, and anybody here can look at the trends and I think draw their own conclusions. But what we do know,
I'm looking for your conclusions. You are the experts. And so, I'm going to turn around and be talking to people, and do I say, we had two experts and they said, oh, the beaver population could be going up, could be going down, who the hell knows? Or are you, with your professional experience and expertise, saying the trend is down and business as usual, that trend is going to continue down?
Okay, well, let me try again. I think that if you look at the data and extrapolate the data, that the trend is downward. I mean, that is the trend of the data is downward. I mean, okay. Now, whether that trend will continue into the future, and one of the first things, of course, everybody learns from a regression is do not extrapolate beyond the data. So the answer, it may be unsatisfying, but we don't know. but the indications are that the beaver populations are certainly in terms of habitat. That is not a population estimate. That was a beaver pool. So the amount of habitat, pool habitat created by beaver dams is in a downward trend. And so I think that I would like to get away from beaver populations because that's really hard to know what they're doing. But we do have pretty good evidence that the number of beaver dams in the Oregon Coast Range are going down. We also know that when the population of dams goes up, that there's more habitat that's ideal for fish like coho salmon that need them to survive. So again, maybe that's unsatisfying, but I think that the larger question really is, do you want more dams on the landscape or less dams on the landscape, given what you know that dams do in terms of their ecological costs and benefits? And if the answer is yes, then let's figure out a way to get more. If the answer is no, then we don't have to do anything. And that's, again, that's back to a policy decision about what you want.
Yep, and we are just right up at the top of the hour, so I'm going to have to nip this in the bud. Jefferson, you got to open the Q&A and you get to close the Q&A. I just have one slide I need to put up about our next meeting. So Jefferson, keep it succinct. Bye, Tom.
I just wanted to say that when we're talking about ODFW and their scope of work, I was really optimistic after the presentation by Derek and Stahl there about the opportunities available to ODFW to impact not only direct take and regulations and such, but there are wonderful opportunities to fund restoration and to collaborate with public land managers as to how they do manage the public lands, and that there's a lot of precedent for that. And so we've heard about how there are various different factors that all have to be in place to have beaver working on the landscape. That it's water, it's habitat, it's beaver, and that the example in Bridge Creek is that those all have to be in place. And so we can't wait for one agency to take over and do it alone. We're going to have to work at it collaboratively, and we're going to have to address all those factors and a large management. So whether or not we think those other agencies are going to come along, we kind of need to make a stand and say, this is important, and we need to change what we can do immediately and try to expand and analyze new different ways to do that, so we can basically set the bar and then hold all the other people that we want to bring along to that standard. So that's what I'm looking forward to. Thanks.
Thanks for those closing words, Jefferson. In lieu of putting up a slide, I'm just going to say, so our next meeting is on October 27th. Thank you. Trap check is 26. Next meeting is October 27th. Again, it's another long meeting. We have a lot of time built in for conversation like we did today, although it feels like we never have enough time. We are working with Brian with the Forest Service and with Brett Roper, who works with him, to provide kind of ground truthing all of this and a couple of case studies and what they've learned in terms of management objectives and restoration, and maybe some takeaways that we can take from that. So that's what's happening at the next meeting. So with that, I want to thank our guest speakers, Jimmy and Michael. Thank you for, if we were in person, we would all clap for you. And thank you everybody for a good dialogue and good set of questions. Looking forward to seeing y'all at the end of the month. If you have any questions for us in between, be sure to call us or email us. All the slides and information that was shared today will be included as meeting summary and posted on the ODFW website. And good night, goodbye to all our viewing public. So